Hello, everybody, and welcome. Good afternoon, good morning, good evening, wherever you are in the world joining us today. We're going to be getting started now with Azure Cloud Development in Delphi through this next 45 minutes or so. So hello, everyone. My name's Stephen Ball, and I'm the Pre-Sales Director here at Embarcadero. And I'm very privileged to have joining us today an MVP who's been working quite a lot in this area, working with the Azure Cloud, which is Glenn Dufke. Hi, Glenn.
Hello, and thank you for having me.
So we've got quite a bit to kind of get through today, but just the kind of quick overview. We're going to be looking into obviously the Microsoft Azure Cloud. What is it? How and why to use it? How to get started using it with Delphi. And Glenn's got some great tips and tricks along the way from his hard-earned experience working through this area. So some great pointers to kind of make a note of through the session. Obviously, the session's been recorded, so we'll make the replay available to everybody afterwards. But we will be having a live Q&A at the end of the session as well. So please, if you're watching this live, just use the GoToWebinar control panel to post in your questions as we're going through. There's some amazing possibilities of things to do, and Glenn's done a similar presentation to this in Denmark recently, which went down very, very well. But he's now enhanced this presentation with a few additional kind of pretty cool cloud functions, things to have a look at. So we're going to get a look at how to do some of the advanced kind of cloud functions with Azure as well as we go through today, which I'm really looking forward to. So, Glenn, Microsoft Azure Cloud, what is it?
Yeah, Microsoft Azure Cloud is Microsoft's answer to a complete cloud package, which means basically a computer is somewhere else in the world. But with Microsoft, there is almost a data center in every country, and that means you can basically pick and choose where you want to locate your services, whether it's virtual machines or running Docker containers or managed databases, you name it. There is a lot of features and bits and pieces you can use to build very powerful cloud platforms in Azure Cloud. And of course, since it is Microsoft that is offering this platform, that means it integrates very well in the rest of their ecosystem, which also means if you in some companies case, they also have some on-premise servers, you can create this hybrid cloud. Most importantly, Microsoft is really focusing on GDPR compliance, which for the viewers that is located here in the European Union, GDPR, which came into effect here a couple of years ago, require that service providers and also cloud providers have measures in place to protect the data we store in the cloud, and also essentially minimizing a chance of a data breach.
Yeah, a lot of it's to do around with kind of the location of data and the jurisdictions that data falls under, and a whole load of other things. Yeah, GDPR is a really kind of cool thing from a customer's point of view, but one of those things that you just have to manage, and it's great to see the kind of the different data center configurations now that are available, and obviously one of the other benefits, especially with kind of some of the IoT business cases that we're seeing kind of push into the cloud now, you need to have data centers closer to the point of origin for the transformation of things, because some of the new ultra low um, latency use cases around things like VR and getting tactile
Yeah,
feedback, all those kind of bits. You need to have the data centers close by because you can't change the laws of physics. You're still limited by the speed of light with data moving down
true.
cables, and so yeah, it's pretty cool, and it's nice to also, some of the back end bits that I've seen, being able to literally just say, yeah, move that from this data center over to there, and just re-replicate the whole thing, across the stack, which is pretty cool.
And I would also like to mention one of the big pillars when it comes to cloud services and Azure in especially, is the concepts of big data and data lakes, which is essentially a huge amount of unstructured data you can tap into and extract information and actually use it to, for instance, build advanced data models. There is a huge potential in the whole cloud platform. You can where you have great features you can leverage.
Mhm. Yeah, I think so just the in terms of the Azure setup now, I think the marketplace on Azure now has got about 200 different products and cloud services that you can choose from, to be able to integrate into the solutions you're building. So I know, uh, I've looked in the past at things like the translation services, the open APIs that you can use and you can connect up to with the REST debugger, and integrate in, and there's a whole set of different things in the marketplace, from artificial intelligence through to image recognition, loads and loads of different things that you can kind of pick up and use, which is pretty cool. And
Yeah,
they're all kind of, a lot of them are built on the kind of microservices type of model, aren't they? With REST endpoints to be able to connect into. But then you've also got the kind of the more infrastructure part of it, with the kind of the physical machines and the data layers and everything else like that, which are more kind of part of the architectural design, rather than the pay per use type of services that are part of the cloud.
yeah, and also, especially when we're talking about um, all the microservice architecture, which we're also going to touch a little more about later here, is when you have a service and suddenly you have a huge influx of requests. In a normal circumstance, if you were hosting your own servers with your application stack, um, you could actually run the risk of your servers were becoming overloaded, and that
Hmm.
means your service became unavailable. Here in Azure, you're basically quote unquote have a valve you just can turn up. So in case you have a popular uh, cloud service, and you start getting a lot of requests, you can turn up for the capacity. Of course, that comes as a cost, but you can scale with the amount of load your service requires. So that's really cool.
Mhm. So, do you want to kind of start getting us into a little bit of the kind of how to tap into some of these bits? Now, I think the area you're going to look at specifically here is around having kind of a hosted machine, really, which you're able to kind of deploy your application stack out onto, isn't it?
Yes. So what I discovered when working with the Azure platform, and the projects I've been involved in has mostly been around virtual machines. I found it actually very handy to take advantage of SSH, or the secure shell. Um, Secure shell is something that is commonly known from Linux and other Unix distributions. But recently, Microsoft also integrated both an SSH client, and you can also install an SSH server on both Windows 10 and Windows Server. And one of the features that has actually been in the SSH protocol for ages is the ability to tunnel traffic over a secure tunnel. So you basically can map a local port on localhost to your remote IP. And in this case here, we can actually remote into our cloud virtual machine and set up some port forwardings which match to, for instance, our PA server, remote debugging, the web server, and with Windows, we can even tunnel remote desktop. So that means we only have to expose a single port while we're doing development and testing, and we can actually access a lot of different services on the remote system. And of course, when you're ready to go live and you have performed all the testing, you can of course configure the Azure firewalls to expose the correct services. And
Sorry, Con.
yeah, and it was especially when I started doing remote deploying and debugging with Linux machines where I really came to appreciate SSH tunnel forwarding. So, yeah.
Yeah, I was going to say the PA server is a fantastic way, directly from the IDE to be able to push the files you need to a remote machine, and being able to use the SSH is, a great way to then be able to bridge your development machine, your development environment, up to that remote instance. If you're not familiar with PA server stands for Platform Assistant. So our Platform Assistant server. Basically, within the RAD Studio installation, when you install it on your machine, if you go to the installed folder, you'll be able to find there's a directory called PA Server, and in there there's the installations for Windows, Mac, and Linux. And you can just copy the installer onto your remote machine, run the setup. Takes a few seconds, just next, finish, and you can then launch PA Server, which is a command line tool. And then that basically acts as the debugging and deployment bridge directly from your IDE. So within the project, if you go to Project Deployment, you can then set up feature files. You can add in specific files that you want to deploy as part of the project. And then when you're connected to a remote machine, you can literally push those files directly from the IDE, which is brilliant. It makes it very much easier than kind of having to put everything and find everything you need into a specific folder to then FTP it somewhere to then copy it somewhere else. You can literally just hit deploy from the IDE and it will ship the whole lot up. And that's especially useful if you're using things like RAD server, which I think you're going to mention a little bit later on.
Yeah,
So with the different packages and so on, it makes it a much easier deployment to do that. It simplifies the whole process dramatically. Um, and it also allows you then to be able to remotely debug across directly from your machine onto the instance in the cloud as well, doesn't it, Glenn?
exactly, exactly. So,
Okay.
so but there are also one thing I really want to touch here, and that is native code in the cloud and why. Um, there normally when you build a cloud service, most developer will say, "Oh, we're gonna write it in C# or um, using Java, Python, or JavaScript for that matter." Um, but there is actually a lot of benefit reusing the existing code base you have, and thanks to the modularity of Delphi and both the RTL and the rest of the frameworks, um, it's actually quite easy to move your code from a traditional client server or even just a traditional desktop application, um, and make it available in the cloud. And part of the reason here is actually you can really reduce your development time, and and you benefit from tried and tested code. And there is also a performance gain since you're running native code directly on the application stack. That means you don't have um, Python that first needs to interpret your code, or um, TypeScript where you need to JIT the code first, or even in the case of C#, if you're using the normal JIT compiler, there's also a performance penalty when you're using these managed languages compared to native code. Currently, with the offerings from Embarcadero, we have 64-bit Intel compilers for Linux and Windows, which are the two stacks that are currently readily available in Azure. But with the emergence of much more powerful ARM processors, we've also seen that Amazon, you can actually start actually pre-order ARM-based server farms. So depending on how the market moves, ARM will actually become a very interesting target in the future. And when we have seen Embarcadero with the great tool chain stack they have, they are able to quickly address what the market demands, which I
Yeah,
think that's
it's certainly
amazing.
an area that I know the product management team are kind of keeping a close eye on, and you know, uh, there's more, there's growing reasons to look at that area, which is great. Um, as today, most of the cloud infrastructure is Intel based,
Yeah,
which is great, and it's good to see the options coming through. I also agree. I think ARM is going to be an interesting area to kind of keep an eye off for the future. Um, but with ARM compilers already in the tool chain for the mobile platforms, let's say it's an area that we're monitoring for the right time to be able to push. Um,
yeah,
the thing that certainly from a why in the why you use the native code. Um, it's not just about the speed; it's also about the cost, the ongoing running cost. Because with the cloud, uh, you're either paying for the amount of time that your CPU hours and stuff that you're being billed for, the amount of memory that you're using, and by having compiled native code, it helps reduce the spec of the machine that you require to be able to run the same jobs, which has an underlying minute by minute cost. So uh, it definitely helps in terms of the total cost of ownership, being able to have the compiled code for sure.
Absolutely.
So
All right.
mhm. So Glenn, I know before we kind of move on to some of the possibilities with Azure, um, did you want to kind of do any quick demos of the SSH setup and configuration?
Yeah. Let me. All right. So, in this example here, I'm using the free SSH client called Putty. And together with Putty, there's another tool we also need here called pagent, which of course we have running. Pagent is a little tool that runs in the background and stores the SSH private keys. It is worth to mention here with SSH that it generally operates with a private public key pair. So on your local machine, you have the private key, and on your remote machine, you install the public key into authorized keys, or basically the SSH keychain. That means when the private and public key pair match, we don't have to enter any passwords. The connection is smooth, it's easy. And during the creation of the virtual machines in Azure, you're actually given the option to download the private key, which you can import here in the pagent. So to the actual configuration here, of course, we have an IP for an instance, and it is also worth to mention here, this IP here will be destroyed once the presentation here is over. So no good ideas there. Here in our setup, we can under the SSH tab, we have a tunnel key, and in this tunnel key, we can define the local port number. I tend to choose the high numbers, like in the 50,000, and then you type in here the local remote IP and the target port number. So we have the here's the port for the PA server. We have the Apache web server. We have some database and additional port number for testing when you're running the red server, the dev server component. So once those are set up, you can in the main data tab here, you can set the username if you don't want to type that in. And once you have set up these port forwarding and of course entered the public IP as presented in the Azure cloud, you can open a new connection and it will authenticate and will say, yes, I am authenticated and I now have access to my my Linux instance. And at the same time, also the port forwarding has been enabled. And we can actually quickly test the port forwarding by opening PA server. And there's a note here. So now our PA server is running in the background, and we can go to our project that uses a Linux profile and say edit connection. And instead of typing in the actual IP address of the remote server, we can just type localhost and the local port we forwarded. And when we run the test connection here, it will say the connection actually succeeded. So that means we now actually have a connection to PA server over an SSH tunnel. And that means that the connection between our cloud instance and our local machine is encrypted with a strong encryption.
The other benefits here as well, Glenn, is obviously you can load in multiple different profiles into PuTTY with the same
Yes.
port mappings. So if you're working on kind of a development environment and a production environment, obviously just be careful which one you load in, but it means it's very easy to just have lots of different, pre-canned configurations with the same ports that you set up and then load and push through, and that's kind of hidden out of the way, which is pretty good.
Yes.
So that's an awesome tip and trick. Okay. So I mentioned earlier on, Azure's got these kind of things called functions. So do you want to explain a little bit about what those are and kind of tell us a little bit about those?
Yes. In the Azure platform, we have a feature that's called function apps. And for those who are more familiar with Amazon AWS, similar feature is called lambdas. It is the type of quote unquote serverless, and essentially serverless is a little application with a little web server, which are intended to do a few things, maybe respond to a single URL or a couple of APIs that it exposed. But this little executable runs on top of the function stack and managed by the function stack. And the function stack can either be a Windows or a Linux base. And thankfully, here with Delphi, we both have Windows and Linux compilers. And the interesting thing with these event-driven services is that we can spawn multiple services depending on the load, and you can scale up and down and also scale out with the amount of features you want your application to have. So that's a very interesting area. Personally, I don't like to call it serverless because it indicates that there's nothing server-ish underneath. But the truth is, there is a server, and our application we're running on the stack has a little web server. So I would rather say it's a managed service where you have a framework that is managing the life cycle of your API services here. And if you've been using Azure already, and also, of course, Visual Studio Code or Visual Studio, you probably have noticed that there are extensions to these tools that really simplifies building various Azure features, including serverless function apps. And this actually inspired me to start investigating and building a plugin for the Red Studio IDE that also takes away some of this manual work you have to do to actually create a function app in Delphi. But currently, and also what I will touch on in a moment, is with a little bit of manual labor in Visual Studio Code and the Azure extension, you can actually build a function app in Delphi.
That's pretty cool.
All right.
Yeah, is that one of the ones that you want to show at the moment, or should we carry on down here?
Yeah, we can switch over here to my demo box here. All right. So to build a function app in Delphi, first we're gonna do is to make sure that we have Visual Studio Code installed. And here on the quick start guide in the Microsoft help file on the website, they list here some prerequisites you need to install. There is Azure function extension to Visual Studio Code, and there is the Azure function core tools, which is basically a local version of the Azure function stack. And it also lists the steps required to set up a custom function stack application. Here in Visual Studio Code, I already created my custom project. We have the trigger, which we call Delphi trigger. We have the function definition, which actually defines the authentication level, what type it is. It's an HTTP trigger, what methods it supports. And also here, what is most important, the host file defines the executable name, and also in this case, a command that tells the function stack to pass the URL directly to our function app. And this is due to, under normal circumstances, the Azure function stack will send a JSON formatted payload to your function handler, which you need to parse. But in this case here, we basically just sending the URL directly, and this greatly simplifies how we can respond to this function call. So once the project has been set up, what we can do here is in Red Studio, go to File, New, and select Other. And under the web selection here, we have a web server. And we also want Linux support, since in Azure Functions, you can either run it on Windows or Linux function stack. And we choose standalone console application. So now with the standard template provided here from the wizard, there is some additional bits and pieces included, which we need to comment out or simply remove. Since what we want to do is, as soon as the application launches, we want to listen for the specific URL that corresponds to our trigger. And once we hit that URL, we want to respond to our function call. It's also worth to mention here, in the setup of the server, once the application are started in the function stack, the Azure function stack exports an environment variable called functions custom handler port, and we want to grab this port and tell our web server, which is actually our little web broker application, it will tell our web server which port to listen to. In the actual web module, we see here that we are looking at the path info in the request object, and we check if it matches the URL of our defined Delphi trigger. Here in our example, we're gonna just return a simple JSON object, and that's it. But in more advanced cases, you could pass in some parameters and extract for instance, customer data from a database, or insert information into a database. There are a lot of interesting options you can perform with these functions. So it's just a matter of exploring your possibilities. So now that we have this function app, which is essentially just a little web server, I already compiled the project. Just gonna compile it again, and we'll see here in our Delphi demo folder, we have the exe file, and we have the function information there. It's the host.json, and we have the trigger and the function file here, which was generated by the Azure extension for Visual Studio Code. So when we go ahead here in our PowerShell and run the command func start, and I prefer to have verbose information, so I appended the verbose command line option. It will launch the function stack and expose our custom function here, which is called Delphi trigger. So when we go to our web browser here and do localhost port 771 and choose the Delphi trigger here, it will load our Delphi trigger application, call the trigger, and since it matches the URL, it will return our object. And if we go back to our PowerShell session here, we will actually see that the function stack received the HTTP request, forwarded that request to our application, and our application responded with our JSON object. So if we go ahead and shut down this again, we could actually go over here and modify our JSON value to false and compile the application and run our application stack again. if we refresh here, we'll now see that we actually change the value to false. So that means our function app is working. And the great thing here about using the local function stack is that you can test and experiment with the functionality. And once the functionality is working in the local function stack, once you push it to the Azure Cloud Function app, which you can do here from within Visual Studio Code, that means you have a very good baseline for a working function app. Of course, there might be something you need to adjust in terms of security, certificates, but if it's working in the local stack, you also have something that works in the cloud. All right, so there was a demonstration of how to build a simple function app in Delphi. As you can see here, there's still a little bit of manual work to do, but the concept is here, and you're able to actually leverage the code you already have.
Yeah, that's pretty cool. So obviously we've mentioned about virtual machines, and I see one of the kind of buzzwords that we've got mentioned on the slide here is Docker and Docker containers. So do you want to, is this something you've worked with within Azure, using the Docker containers and bits as well?
I have not used Docker containers, unfortunately. The project I've been working on has had a requirement. It was virtual machines.
Mm-hmm.
I know from a friend of mine who is really into Docker that with the Kubernetes orchestrator, you can quickly scale your services up and down as you please with containers, which when it's set up correctly, it works very well.
Yeah, one of the nice things, with the Docker containers is just when you do launch them, they're instantly on. You have the whole scripting setup of them, setting them all up. It's almost like building it up and having it an instant on snapshot ready to go with all the bits kind of pre-fired in the background ready to push. So they become a brilliant capability for scaling out to deal with those kind of peak loads and requirements that kind of push through, and enable you to kind of have additional kind of web servers instantly there and available to be able to handle kind of requests coming through, which you can then kind of balance over to the back end, which is quite cool. And also with Rad Server, we've got the pre-built Docker container scripts available to download and to use, and so that's a great way to be able to kind of spin up and supercharge your middle tier with Rad Server in the background, which is pretty cool.
Yeah, and also worth to mention about Docker containers that you have a reproducible environment, since when you're building the Docker containers, you actually have a set of what they call Docker Compose scripts, but essentially it's a recipe that defines, okay, which base image are you using, what extra packages are you installing into the container, are there any additional pieces of software you want installed, etc., etc. So in that regard, you have a very reproducible environment.
Yeah, which and that's one of the things that kind of the whole DevOps side of things love the Docker containers, because you've got a guaranteed same environment between development through to QA through to production and live, which always one of the kind of the big challenges is the developers in the past going, well, it works on my machine, and then the DevOps guy, the operations guy is going, well, I've installed it on the machine here and it's not working. What's the difference? Where's the difference in terms of the environment? What's going on? So it does cut straight the way through that and makes life so much more agile, and enables kind of these kind of continuous build paradigms to exist. One of my favorite things I've seen on the Docker container side, if you haven't seen Malcolm Groves's session and video on Docker containers, definitely worth having a look at. But one of the great things from that was being able to spin up and get going, NoSQL database or some other data, Microsoft, a MySQL database, or whatever, different databases, different versions. You can literally spin up a container with that image in it, have your script to build the data that you need. You can then run all your unit tests and everything against it, and you can test rapidly against different versions of different database builds and so on, very, very quickly. And once you're done, discard the container, launch it back up, and you're back to square one. You can run the same tests again, and you'll get the same results rather than having kind of data that's already been modified and messed around with, that you're then having to work out, well, is this test passing because the data's changed, or is it passing because it should pass now? What's the kind of the differences? And it helps kind of cut all the way through that to make life a lot easier to test and reproduce things on, which is pretty cool.
Absolutely.
And I see on here also you've got managed databases marked up, and being able to just spin up a SQL Server. If you need a SQL Server database alone, you don't need to have a virtual machine in the cloud, do you? You can just literally ask Azure to, hey, give me an instance of a Microsoft SQL Server database, and you can manage that remotely through a control panel. And I've done a blog about that previously in the past, and being able to hook up and run with those. And you can use the FIDAT components directly from the IDE. You can connect them directly to, you can connect to the remote database very easily, just using the right ports, or again, using the kind of the tips and tricks that you've just seen with the SSH. You can use that to map the ports through and get the connection going. But they're very, very easy to set up and use, aren't they?
Yeah, they are indeed.
The other thing on here you got is the Blob Storage, and I know this is kind of quite an interesting area. There's Azure and Amazon have very similar kind of capabilities with similar things called different names under the kind of two platforms, but instead, but in essence, this kind of folder or bucket or storage within the cloud that you can remotely connect to and use. One of the interesting things from when I was at Nokia, some of the AI work that was being done there was extensively using the Blob Storage up on the cloud, because actually they're exceptionally fast file access, ridiculously fast, and dealing with high volumes of data that's been collected through, to be able to process those through a Kafka stream or something like that. They actually found them to be a lot quicker because of the way they're set up and manage the data than some other kind of traditional forms of storage. So the Blob Storage is a fantastic thing to use. And again, we've got the components directly from within the IDE for the cloud storage. So they're great to use and to run with.
Yeah, and it's actually very fast to aggregate the data, or for that matter, when you're actually want to just do one way, actually dump the data into the Blob Storage.
Mm-hmm. And the last thing you got here about the scalable workloads. We've touched on scaling quite a few times, and again, Amazon and Azure do great work in terms of scalability and configurations for scaling up, having kind of redundancy and having all the kind of the hardware almost as a service in terms of firewalls and load balancers and things like elastic IP addresses that kind of give you an IP address that on one end you talk to, but on the other end you then kind of flex where it points to depending on what's kind of going on. And all these things are a fantastic in terms of just productivity and what you can do with them, and also the flexibility as well. It kind of just takes a whole level of complexity and cost and infrastructure away from the need to manage it, and then you just pay for what you're doing as you use it. Which makes it so much more accessible. If you've got ideas for testing things and working through things, you can literally spin up the instances that you need with the configuration, test it, and if you need to push it out hard, then you've got the chance to do that with literally a flick of a switch, really, isn't it?
Yeah, it's actually very easy to scale, especially when you have the big workloads and one of the cool thing I've seen is actually live migration of services from one data center to another within Azure in the Azure platform, but that was actually from one data center in one country to another data center in another country, and that happened on the fly, no service interruption. Yeah, that was pretty cool.
Okay, cool. So I think moving on, was there anything else that you wanted to kind of mention on the possibilities around Azure and the cloud? I say there's over 200 products and services that make up the cloud, and and Glenn's kind of touched on to some of the kind of the serverless type things with the functions, but also the kind of the instances of a virtual machine, which is a bit more like the local cloud data center that that are quite common around. But yeah, over 200 products and services to be able to connect up to, which
yeah, I mean,
definitely worth spending some time on the marketplace and having a look through them.
Exactly. I mean, what we covered here is one of the most relevant pieces when you approach it from a Delphi developer's perspective. It's probably those tools you're gonna interact with the most, and I would probably say that makes up the majority of any cloud service, not just Delphi, but any cloud service you build is either VM instances, Docker containers, and of course function apps. So yeah, that's it's pretty interesting.
Okay, so I think that's pretty much bringing us to the end of the time that we've got here at the moment. We've say please go ahead and use the GoToWebinar control panel to post any questions that you've got for Glenn or myself. Hope you found this this interesting. It's certainly been pretty cool having a look at some of the latest updates around the server functions and how we can access those directly from within Rad Studio with Delphi. But yeah, let's open up the Q&A.
Yep.
Okay. I see a lot of questions beginning to pop through already, which is great. Thank you. Keep those coming through. I see a few have been answered, but we'll work our way through them. So, Glenn, are you there with us? Can you hear me?
I am here. Yes.
Superb. Okay, I'm just having a quick look. There's I'm just going to share quickly here. Oop. Sergio just sent through a link linking to an example that he's put up on GitHub for using a data lake store with Azure and Delphi, which is pretty cool. So I've just gone ahead and shared that through into the chat as well. Okay, thanks, Kevin. Okay, let's just jump down the questions here. There's a couple of questions around PA Server and using PA Server through Azure. So I think the key thing really here is PA Server is really used for installing onto a Windows instance, onto a virtual machine. So if you've got a hosted machine in the cloud that you're using, and you're using kind of the infrastructure within Azure or in Amazon, it really doesn't matter. It's a virtual machine is a virtual machine, is it's Windows running or Linux running somewhere, and you can install PA Server onto that. There's a couple of questions around using PA Server within function apps. Function apps are kind of slightly different. They're kind of like a standalone function in essence, application. So you really wouldn't be deploying the function app with PA Server and then pushing the stuff up, because they're here and they're gone. They're not kind of physical infrastructure that exist and persist, if that makes sense. So it's slightly different use case. So we've had a look at the two different things. I hope that kind of clears it up for around those couple of questions. Anything to add on that, Glenn?
Yeah. Let's see.
So yeah, a few of the questions at the beginning are ones that were covered in the demos. Can we use Delphi code within a function app? Well, yeah, absolutely.
Yeah,
And there was a couple of questions about. Yeah, sorry, go on.
There was also a question here about if you could use a DLL in the function app. And the way the Azure function stack runs is basically it expects an executable with your functionality. It can spin up, and you can do whatever you want to do in your function, and then the Azure function stack can tear it down again once it's not needed. So you would actually have to compile the DLL, use the code in your application instead, or compile it into an executable.
Okay, so if you've got third-party libraries that you need to use for some of the calculation or something, then you're not going to be able to use them through the function app. Is that right then? Or are you able to statically link the bits in? Or
yeah, you need to link the bits in that case, so you don't have any external dependencies.
Okay, cool. There was a couple of questions here around the example that you put together and showed with function apps there, and just how to get hold of the code, or how to kind of create their own version of it.
Yeah. As I'm also mentioned here in the chat, that I will provide a blog post and a demo GitHub repository specifically around the steps required to set up a function app in Delphi and how to build it. So that will come up shortly.
Cool. And Charles asks a question here in terms of the difference between running costs for function apps versus having your own server. How does it work in comparison? Do you know much on the pricing side of it?
You can actually choose how you want the availability to being charged. Like you can actually tell Azure, okay, I want my function available at a premium level. That of course is more expensive, but you can also choose to take advantage of the capacity that is not in use, and that means you can actually have it running at a lower cost. So you have various options to define how much you want to pay in Azure, and of course it also depends on the level of availability of your services.
A question here, any pointers towards using Azure or Amazon Web Services or vice versa? I think each has their merits. The one thing I would say is that there have been a number of changes over time. Certainly, I did a sample doing some translation a few years back, and I kind of realized just the other day that the APIs have actually been kind of deprecated and removed. It's the old version from about 5-6 years ago. So it is something you need to kind of be aware of. Have a look at the different backward compatibility around APIs if you're using kind of additional services areas. Yeah, both of them offer kind of similar and yet different kind of options and capabilities. A virtual machine is a virtual machine. The stack is, you just got to get familiar with the different ways of doing the kind of same types of things really between the two of them. I don't think you're going to have a bad choice. And what you're probably going to find is that if you're looking at the different services, and one of the great things about the kind of the microservice infrastructures that we see around now is that your backend will be kind of the mediation point for your application. And then within your backend, you're then able to define out the kind of the APIs that you want to go and use to reach out to these other services. So if you want to switch from one to another, then you can do it quite quickly and easily. And that's a really good reason to be using something like RAD server and have RAD server running and having everything connecting in through your RAD server instance. Because then if you do have breaking changes in the backend, you can just update your code on the server, and then suddenly all the apps are going to be working with that absolutely fine again because your API hasn't changed. And that's the one thing that you can control. So a bit of a different answer to the question, James, but I hope that kind of gives you some pointers. Yeah, just get on and have some fun with them. And the one thing I would say is if you're looking at consuming any of the additional services, definitely check out the REST debugger. Playing around with the REST debugger is a great way to be able to just check and make sure things are working. And then you can just copy the components and dump them into your application and off you go. So that's a great way to use some of the things like the translation services or the Face ID APIs that are on Azure now, or any of the other kind of cognitive services. They're really easy to kind of connect into via REST, and you've got everything you need in the toolbox there. So. And Charles asks here about the time to spin up a function versus a traditional server. Do you want to handle that one, Glenn?
Of course, especially when we're talking about using a custom function app, which is natively compiled, versus if you have been running or written your service in a managed language like C# or TypeScript or Java for that matter. There is, of course, a very slight penalty when it comes to cold starting the function. And of course, again, it really depends on the allocated CPU time. Like, are you paying for premium allocation, or you're paying for, allocating on excess available at a current point in time. at a lower cost. That of course dictates how quick or how slow your function takes to spin up. But generally speaking, your function is a little web server. And of course, if you have to wait for a connection to a database or something else that needs to be in place before your function is ready, that also takes some time. But with my testing, spinning up function is near instant. So yeah, time-wise, it's I haven't really found it to be an issue.
Okay, cool. And I think the final question here is just one about Ssl certificates for the function apps. Who takes care of these?
Right. That is one of the many great benefits of when you're running on a platform like Azure, is that you have the whole environment to manage Ssl certificates and what is required for like your DNS records and domain names. So you can manage Ssl certificates and all that through the Azure portal.
Okay, great. Well, I think we're pretty much at the end of the questions here. Final quick question that someone just put through here. Are there any more examples for using Azure function apps with something a little bit more complex than a Boolean? Well, I think the key thing there is we've just done a really simple one just so you can see how to create the body to send back. What you send back or what you handle to push back is exactly the same as any other web request coming in and out. And you can build your own JSON strings and packets to push data in and out. So there's lots of functionality within your RAD server for doing that. So definitely pretty easy to have a look at any of the other samples that are doing JSON handling, and you'll be able to see what to do with that. And again, if you want to have a data module on there that's connecting up to a data instance, and then fetching data and then putting that into a format to send back, that's all possible to do. It literally is just down to you in terms of what you want to do here. But this is just kind of a 101 example. I don't know, Glenn, if you've got any other examples that are going to be in the repository you put up, or if it's just going to be the quick and easy one to get going now.
The repository will contain a couple of examples. Of course, the example I showed here in this webinar, and also an example that shows how to parse parameters from the URL. So you can actually append to the URL that points to your trigger. You can append additional parameters, and you can grab those parameters and parse out the values and do something with those values. So there will also be a demonstration of that.
Okay, great. There's a couple of questions that have come through that are kind of out of scope for the kind of session today, really kind of looking and asking around kind of roadmap for the future versions of RAD Studio and Delphi and so on. Yeah, the best thing I can say for those is please have a look at the kind of the roadmaps that are published. If there's specific things that you're after, then feel free to kind of drop me a message through specific areas that you're looking at or that you have requirements around. more than happy to pass those on to the product management team as feedback. So just please email me through on stephen.wall@embarcadero.com. But I think we're kind of a bit over the hour now. So thank you everybody for all the lovely messages and for joining us today. Thank you, Glenn, for the presentation and kind of the really interesting kind of look at the function apps and so on. So I think that's it for us today. Happy coding, everybody, and we look forward to welcoming you back very soon. Take care.
Thank you. Bye-bye.
Hello everyone and welcome to this webinar today. This is an introduction to Interbase, where we're going to be getting right into some of the key things to understand and be aware of around the product and to help you get going with building your first applications. My name's Stephen Ball and I'm going to be your presenter today. I'm part of the pre-sales team here at Embarcadero, and in the past I've also been product manager for Interbase, so I know a pretty good amount of detail on the product. So if you do have questions, please go ahead and post them into the GoToWebinar chat if you're watching this live. If you're watching this on demand on YouTube or somewhere else, then please feel free to email me. My email is on screen there if you have any questions or need any pointers in the right direction. So our agenda today, we're going to start off having a look at what Interbase is and why it's been chosen by lots of companies around the world for some really cool applications. And we'll touch on a couple of those as we go through. We'll be looking at that as we find out where Interbase is being used. And primarily, this is heavily used in fields like medical, in finance. It's used an awful lot in kind of embedded systems or deployed systems where you really need to make sure that the system just keeps on running and you don't have a full-time DBA on site. It's a very robust application platform to build on. So if you're looking to choose your database, it definitely is a great option for those kind of deployments as well. We'll have a quick look at some of the connectivity options. There's a lot of different languages and programming environments you can connect to Interbase from. But then the core of this presentation, we'll get into actually doing some development with Interbase. We'll go ahead and look at how we can connect to it from our first desktop applications, how we can use it across onto mobile. We'll look at some of the deployment options and the tips and tricks around that kind of area. And also the Interbase API, which allows you to programmatically do regular kind of tasks like adding users, backing up and restoring the database. If you ever have kind of hardware system issues and you might have kind of a corrupt hard drive, there's APIs to be able to validate and mend and fix the database file. So even minor corruptions on the database can be fixed and sorted out by Interbase and get you back up and running. And as I say, you can do this all programmatically directly from the API without having to have a DBA on site. So let's get in and see what Interbase is and why people choose it. So, what is Interbase? In a nutshell, Interbase is a full-featured, high-performance, ultra-fast database. It's encryptable, which means you can look after all the kind of the key requirements around GDPR with data encrypted at rest. And one of the great things about the encryption within Interbase is that there's very granular encryption right down to the column level, and you can use multiple encryption keys within the same database. So for things like PCI, credit card information storage, you can ensure that any details that you have to store are encrypted using a different encryption key to data that other users might be able to go ahead and access. So it's great in terms of building up different roles and responsibilities, providing ultra flexibility in terms of what you're doing. In terms of scalability, Interbase is great from an embedded systems point of view when you've got a single machine running a POS application on a really old bit of hardware, right the way through to having hundreds of users connected simultaneously across a network to a high-powered server. Interbase comes with 8 cores out of the box on a standard server license, 8 cores included. So you really, as your application grows and your number of users grow, you can just add additional users to your Interbase license and scale up and take advantage of the memory and the processors and everything on your server to kind of make it scale up. But equally, it happily sits on a mobile device. So Interbase really does perform across a whole range of different platforms. And that kind of comes into the next bit. Interbase is very much about multi-platform support. Now, from a developer's point of view, if you're developing for mobile or desktop or both, having the ability to develop on your development environment with, for example, running, building on Windows with your IDE, working everything through, and then being able to literally copy that database file and deploy it across to Linux or to iOS or to Android or to Mac OS. That makes the whole development cycle so much quicker and easier. And also from a testing and development point of view, having the same file format that works everywhere just helps speed up that kind of testing that's required, because you don't have to go through a whole load of additional testing for each additional platform. And one of the things that's very cool with Interbase is the whole data security and data disaster recovery setup. And one of my colleagues, Mary Carey, did an excellent webinar recently on the whole data security and disaster recovery side of things. So definitely check that out on the Embarcadero YouTube channel. But the crux of it is, Interbase has great options for both speed and performance and also disaster recovery. Things like journaling and journal archives, which mean you can actually roll the database back to a specific point in time. If you do something really silly, like delete photo from customers, running that as a SQL script, which I actually had many years ago. One of my team members, a CEO of a company, thought he'd help out on the support desk at a company that was running Interbase, and he managed to wipe out the customer table, literally everything, by not understanding the SQL script that he was running. Thankfully, point-in-time recovery, we're literally able to roll it straight back and get the database straight back to where it was. So very, very easy to get it back up and running if you've got journal archiving enabled. And the other great thing about journals is that they provide write-ahead logging to enable you to get the maximum performance out of the memory with the database, reducing the amount of impacts on the disk to reduce the bottleneck from any hardware. So it really does, there's a lot of server-side capabilities that really make Interbase scream and scale, which is why it's really, really popular with OEMs, especially when they have customers that could be 1 or 2 machines right up to hundreds. So I think we've kind of covered a few of the kind of key points here. In terms of a compliance point of view, obviously standard SQL, It's got everything in there from an ACID compliance point of view, and that powers some of the actual quite clever and patented technology around change synchronization. Interbase has this really cool feature called change views, which allows you to run run your connection to your database, start your subscription, run your query, get the data, and then commit. And then later on, at a different point in time, you can reconnect to the database, activate your subscription, run the same SQL statement again, and you will then just get the delta and get told at a field level what has changed since you last collected that data. And because Interbase is aware of having data being written from different locations and back and forth, you don't want to kind of have circular movement of data. It knows if you've written something in, it's not going to send you that change back. If you have got a big lot of changes being written at the same time as you kind of put some change in and pull back, it will wait till those changes are committed, and once they've been committed and they are into the database, you'll then get that entirety back, even though those changes started being written before your transaction started. So it's really, really smart in terms of making sure that you get everything you should get at the time you should get it, and not get the stuff back that you don't need. And this is why we're seeing Interbase heavily now used alongside other databases, specifically to get that change tracking technology brought in as part of a holistic kind of deployment. So I've touched on a few of these as we've kind of been going through, but just drawing on a couple of the little bits here. The different types of encryption that we have within Interbase, and we have a DES, which is the weak encryption but still encrypted, and then AES with up to 256-bit encryption, which is really used for strong encryption. That's the one that's recommended for live deployment. You have the options to be able to use both at the same time in the database as well, which is pretty cool. And the way that the security and the encryption works, you can be really smart using the roles, the user authentication roles within the database. So for example, if you have a HR team, human resources team, and you might have a marketing team and a sales team, you can set encryption and decryption based on specific roles that people play. And then you just assign those roles to specific users, and then that user can then see or not see specific parts of the data. And you can set default values as well. So for example, if you had a HR table and you don't want the developers to see everybody's salary information, then you can set an encryption key on the salary and set a default value of 0 to be returned. So if you don't have the rights to read it, the SQL will still run, but the data you get back will just be the default value because you don't have the rights to read it. So in terms of what you can do, it really makes it very clever and capable of protecting kind of the business rules around the organization as well. So I want to talk a little bit now about the different versions of Interbase. Interbase comes in primarily two versions. There's a version that you install and sits and runs as a service on your machine, and that's the Interbase server. It's on Windows as well. We also have a desktop edition to do with the kind of the configuration options that are available within Windows, and we can tie it down to allowing only the IP of the local machine. And that works being able to provide a desktop edition, which allows you just to have multiple applications connecting to the same database on the same machine. The server version obviously is the same. It just allows you to connect to the database from remote machines. So if you've got multiple users connecting in from multiple locations, you put a copy of the Interbase server in place. Now that runs on Windows, Linux, and there's also a Mac OS version of the Interbase server available. In terms of Interbase to Go, Interbase to Go is our deeply embedded version. So what that means is that there's libraries that you ship alongside your application that are basically the Interbase engine, and they are bound into your application at runtime and start Interbase inside your application. So blazingly fast, because the database is inside your application memory space as well. And as your application starts up, the database is there. When your application closes, the database is shut off. And it only allows your application to connect directly to that database. It doesn't allow remote connections. Now, Interbase to Go is also available in a free version called Interbase Ib Lite. Now, Ib Lite doesn't have all the features of the standard editions of Interbase. It doesn't have change views, it doesn't have encryption, but it provides you 200 megs of file disk space storage for Interbase. So it's a great way to kind of get up and running and have Interbase inside an application. The Interbase to Go is available on Windows, Mac, iOS, Android, and Linux. So it runs across mobile and desktop platforms, which is fantastic. It really makes it a very, very easy database to build on your development machine and then deploy out anywhere that you can target. So we've spoken a little bit about Interbase, some of the features, what it is, where it's used. That's where we really want to kind of have a look in next now. So one of my favourite stories of Interbase is actually there's a copy on the Mars rover. Apparently it's a bit too hard to get a DBA up there. No problem, Interbase is up there. It's kind of exceeded its mission parameters, it's still running. It just shows you how kind of robust it is at keeping going. I say the ACID compliance and the kind of the way Interbase works with its small disk footprint, low memory utilization requirements means it's ideal for whatever type of system is being deployed and embedded anywhere. There used to be a copy of Interbase on the space shuttles as well, controlling all the cargo manifests going in and out. Building the space stations and getting all the other kind of stuff up and in and out of space. Interbase was behind a lot of that as well. On a slightly larger scale, this is one of our customers from the Nordics, Opus Capita. Now they provide accounting receivable and accounts payable software, doing invoicing, processing, everything's automated and managed through a SaaS solution they provide out to their customers. Now at peak time they're providing over 500,000 new records a day are being processed into their Interbase database. And they're all financial records, with critical part of the supply chain, and it just sits there and runs off a single server quite happily. They've got a small development team who've been building with Delphi and Interbase for a long time, and the application's also connected up to a web interface which they use. I think it's IntraWeb that they use for that. It's great at being able to provide out everything they need. And the one thing that they really love about Interbase is using the stored procedures and triggers. Being able to move some of the logic directly inside the database makes it exceptionally fast. It really is a great way to make Interbase scream. And by being able to write it in the data layer, it then just works on any platform they need it to. Another one is Bonev. Now, Bsoft, they provide leading accounting software and auditing software that's used by people like PricewaterhouseCoopers and the Bulgarian military. It's been kind of certified to run on their internal networks and so on. So it's used in a lot of different places. Their customer base scales from 1 or 2 machines up to hundreds of users. And they have to support kind of things like ISO 27001 accreditation. So things like the user roles and the user security setup and configuration in Interbase is a real key asset to them in terms of being able to support those kind of accreditations. One of the things that they absolutely love about Interbase, they've been a VAR for quite a few years now, is that the additional features that come into Interbase over time are things that they're able to bring back to their customers. So when encryption was added, when the new write-ahead logging was added, when additional kind of disaster recovery features have been added over time, they're able to just upgrade their existing customer base with the data layer, and in most cases just update the database part without having to redeploy all the desktop applications. And they're being able to provide additional features, speed, performance, and so on. And they've been able to take large swathes of their existing product and transfer that directly over to mobile, including data structures and so on, because they're running Interbase. It just makes it very, very easy for them to have a single platform to work with. From a support cost and a training cost for their staff and maintenance, it helps keep their costs down, which means that they can provide a real competitive solution within the marketplace, which is a key reason why a lot of people use Interbase. That's just a couple. There's many, many more. Things like Management Plus, who are using Interbase within the medical realms. There's a lot of the kind of the body scanners and things like that around the world at airports and within hospitals. Big MRI scanners. They're also using Interbase, have it deeply embedded in. But I definitely say go ahead if you're interested in these kind of stories. Go and have a look at the interbase.com resources page on the website, and you can dig into those a bit further. So in terms of connecting to Interbase, if you're using Rad Studio, very easy. You can use the FIDAC components just to drop down, and we're going to have a look at that in just a moment. But additionally, there's ODBC and JDBC drivers. And also recently we've just launched an updated ADO.NET driver as well, which you can download from GitHub. The links for that are just on the screen there. There's also packages available in NuGet for both Interbase and also for working with the entity framework on server side. So that's great for Interbase. There's also additional things, connectivity out there that you can get for Ruby, for PHP, for Python, and so on. So wherever you're developing, basically, you should be able to connect into Interbase without any worries. So let's get into some demos now and actually see how we can use Interbase. I'm going to focus on Rad Studio today, and but obviously, any platform you can go ahead and use Interbase. Okay, so let's go ahead and we're going to build a kind of a sample application just to help us look at how some of the different things work with Interbase here. So to start off, let's go ahead, and our first iteration here will be a VCL application. Now, I'm going to use an existing database, but just to show you how you can connect to different databases, let's just go ahead and open Ib Console here. Ib Console is the kind of the interface for Interbase that comes out of the box, and you can also use things like Aquadata Studio, which is a whole fully fledged database IDE. Great capabilities within that, and that's included as part of the Architect Edition. Let's go ahead here. I'm going to add a database into my local server configuration, and I'm going to go to this computer, C users, public documents, Embarcadero, Studio. I'm just going to go to the samples that are shipped with the product, because there's a data folder and we can connect to one of the databases. So this is using sysdba master key. And here we can see the database table. Domains. Now, domains are really useful in terms of Interbase. They provide you a way to, let's just bring those back out here. Domains provide you a way to define a specific data type and then have some validation around it. So for example here, a budget is a decimal of 12,2, and it has a value of between 10,000 and less than 2 million. So you can put logic inside the database, and the great thing here is you can add these used through the UI, but you can also see the SQL text, the metadata for how to produce them, and you can see dependencies here in terms of what tables they're being used on. So for example, I can see the departments table has a budget field which uses the budget thing, and there's also a project department budget which has got a projected budget, and again that domain is used there. Now these are really useful. Here for example we've got an address line. If you suddenly realize that you need to change your address lines to be 50 characters, you can just update the domain, and that will then reflect across the entire database, which is quite useful. So domains, really, really useful. You can create, alter, drop, do a whole load of work with them directly from here in IB console. Again, tables. Here we've got our tables. So let's open the employee table here. We can see the fields. We can see the data types that they're set up as. So for example, here we can see this is a job grade. In brackets, this is the domain. And this domain is a small int. Again, we can see under the metadata, we can see all the domains that are used and how they've been set up, the actual table, and we can also see any additional relationships here. So for example, this has got a foreign key constraint. The department number must reference a department number within the department table. So again, all the referential integrity. There's some advanced checks going on here that the salary is greater than or equal to the minimum within the jobs table. And less than the maximum. Again, this is all kind of stuff that you can build into the data layer to help protect rather than having to put it into code everywhere. We can see the indexes that have been built. A lot of these get automatically built, but if you want to have specific indexes, if you're constantly looking up on specific fields, you can go ahead and create an index into Interface. Views, this gives an example of a view. Where we're selecting specific data from a table where the department number equals the same as the department number. So you can see here we've got a join between the employees in the department table going on. Stored procedures allow us to run specific logic on the server side. Again, here there's metadata, so you can see how they're created. And these are great for going through and learning, but also have a look at docwiki.embarcadero.com and have a look at the Interbase online help there to learn all the syntax. But looking at the examples here, you can really pick up a number of different things. And this is great in terms of being able to build up and return back data almost like a table. You can run a select statement against a stored procedure to get the data back, which is pretty cool. Triggers here. Triggers run events on the data tables before, after inserts, updates, deletes, and so on. You can set the triggers to be active and they go ahead and do certain things. So for example, this one here, this is before insert on the customer table, and it's a sequence, so it's at 0, so it's the first one that'll be done. It will just set the customer number to be equal to a generated ID number from the customer number generator. So this is creating an auto incrementing field as you create data directly on the table. External functions allow us to have extensions to the Interbase language on the Interbase server and desktop editions, and that allow you to write modules that you can bolt into Interbase. And there's a number that you can download and add in that provide additional features already. Generators, again, these are unique numbers. So if, for example, you're adding in a customer and you need a unique number for each customer, you can put a generator into Interbase and use the generator value. And you can call that programmatically just to get the next number from the generator, and off you go and use it. And likewise, as we've seen, you can call those directly from SQL. Interbase exceptions allow us to provide kind of custom exception messages if something happens and it's kind of not right. For example, here, unknown employee ID. If you try to set something in with an invalid employee number or project ID, this exception is fired up. So again, exceptions are a great way to control and validate and provide rich information back to the end user about what's happening in the data layer. Blob filters are able to kind of work with different types of binary list of bytes fields, so be it images or text, memos, and so on. Files, you can put them into blob fields when it's kind of you're not quite sure what it is or how big it's going to be. You can throw it into a blob field and then have different filters to work with that. So they're really popular for things like JPEG or MP4s or whatever you want to store in the database. You can go ahead and use a blob field. Roles allow you to add additional roles into the database, and that comes into the kind of having a HR role and a finance role and a salesperson's role that you can then provide different security access to different parts of the database on that role. And then for the users, you can then go ahead and add different users into the database and then provide those roles onto those users and sign them on. Now you can embed user authentication inside the database, or you can use it on the server. So hence there's the option here for both within the system. So we've had a quick look at the table there. We've had a quick look at some of the kind of the key features. How we use those within the applications is primarily through components when we're developing with RAD Studio. So for example here, the Data Explorer is a great way to be able to quickly connect to an interface database within inside RAD Studio. So under the interface section, under FIDAC here, we can add a new connection, call it whatever you want to call it, and that will pop up the dialog. It's the same here as the employee one that I've got pre-configured. You have your username, password for your database. I'm going to turn off the monitoring here at the moment. I don't want to have that on. But you can modify and you can monitor your connections remotely and do some great stuff. Here this is running on TCP/IP. That's fine. That's absolutely fine. We've got sections in here for things like the set password if you're using encryption to put that on. If you're creating a database on the go, then you can set this to either create the database as it opens or open or create. So if the database is there, open it, and if it doesn't exist, go create the file at the location that you told it to be. You can then check for tables, and if they don't exist, create the tables. It's really useful for creating databases on the fly. And I'll show you that actually in a minute with an application that I've got running on mobile and how we can set up and deploy to mobile. Quite useful within the connection is to be able to run a SQL directly on the table. So for example, select star from employee. Here we are, we can see that the connection's worked and we've got the data directly back. This is really useful to quickly see some data, or also to make metadata changes to the database on the fly as you're developing. If once you get familiar and you're comfortable doing it through SQL, you can do it directly from inside the program. Here we can see the different tables, we can see the generators, the procedures, the views that are all in that database that we just had a look at. We can do things like taking the employee table, just dragging it on. Let's put the the department down as well. Let's use a couple of data sources here. And go ahead and link these to the different tables that we've got here. Oops, so let's choose the data source, connect that one to the employee, and we'll call that DS employee. Connect this one across here to the departments. And let's go ahead and update the SQL that's generated here, where department's number equals the department number. So I can just check that that executes. This full colon here tells RAD Studio this is a parameter, and that parameter is going to be fetched from the master configuration here. So the master source is the employee data source, and we're going to choose the department field to be included across there. If we go ahead and just set these to active, and we can visualize that here quickly with a couple of DB grids. If we could just connect the first grid to the employees and the second one to the department. Let's just go ahead and run this here quickly. You can see as we move through that it's picking up and doing the master detail relationship for us, to be able to see the details linked through. So that's quite a quick way to kind of get going. Now, obviously, what I'd say here is some not great practice in place. Let's go ahead and just on the project here, go ahead and add a data module. So I'm just going to go new, other, and we can search for a data module. And if we go back to our let's just go back here. And if we go select these components, and let's just take those, put them on the data module here. And the other thing that we want to put on is the wait timer. So we've got the SQL wait timer here. That will just control the mouse cursor if we're doing kind of updates and posts and stuff later on. Let's just come back here, and we really should save this with a sensible name. So let's just go ahead and save everything here. New folder, IB demo. And yeah, let's change this and say this is our data module main. And let's go ahead and save this as BCL main form. And let's change the project to BCL IB demo. So on our main form here, let's put down a navigator. So a DB navigator. And let's go ahead and align this to the bottom quickly. Align this one to the bottom too. Now we don't need it to be too big as it's only a single row. And we'll set this to be to the client. We can see, yeah, that looks a bit better. Oh, one last thing to do. We need to go ahead and add to our uses. And let's go ahead and reconnect this to the department and to the employee. So there we are. We now got that all working. Our data is separated out a little bit, which is much better. So obviously I can go ahead and customize the UI and do a whole load of other bits here, but that's really not the point of this webinar today. So let's go ahead and save this project. And I'm going to go ahead and add a new project into the project group here. And I'm going to build a mobile application. So let's go ahead and we want to have a multi-device application here. And let's just take a blank application. And let's go ahead and well, we'll just do a desktop application for the moment, and we can show you the same thing working with the data set and working across different platform, because then you can see how you can deploy this out onto mobile. Let's go ahead and add in a grid here. And let's take a couple of those. And a navigator. And if we add into this project, in fact, let's just save the project to start quickly. I'll put it in the IB demo folder here. FMX main form. And the project's FMX demo. And what we can do is we can go ahead and align this to the bottom. Let's align this to the bottom as well. And again, similar thing, we can now just go ahead and use the unit. Need to add it in first. Add data module. Okay, so the reason I'm getting a message there is just about the configuration between FMX and forms. So let's just go ahead and I'm just going to update this to be system persistent. That will work out the one as we run. And we can now go ahead and bind visually. Let's just refresh the design here. There we are. So let's select the first grid here. We're going to link that up into the employees. And the second grid will link to the department. And the bind navigator will pick up the employees as the data source, which I think is on bind source 1 here. Employee table, bind source 1. There we are. There we are. We can see as we kind of move and navigate through, it's picking up and processing, same as the other application. So we're able to share the data module. We've just rebuilt the same UI as a desktop module here. Obviously, we could be looking now to deploy this out using Ib Lite. If that's the case, then on our data module, let's go ahead and update. Let's have a look on the design side. We need to update this to show that we want to use Ib Lite. And the way we do that is using the physical driver link. So here we are. We add the Ib physical driver link down. And we can set this to light, and that will set it to use the Interbase to Go. And when you deploy it with Interbase to Go, you need to have the libraries for it. So under project deployment, if you come in here, you can add feature files, which is add feature files here. And we can add in Interbase to Go. And here it will pick up all the Interbase libraries for the platform that we're building and deploying out for. As you can see, all the Windows, Linux, Mac OS, and everything are listed in here. Now this will put everything from the redistribution folder. So if we actually come down here, users, public, documents, Embarcadero, Interbase, redist. This is the base redistribution folder. Now currently the redistribution is set up for Interbase 2020. And then here you can see all the different files for the different platforms that get picked up and pushed into your application. Now, this is an important location because if you're going to use Interbase to Go, with the Enterprise and Architect edition of Rad Studio, you get a royalty-free runtime distribution license. You'll need to go to reg.embarcadero.com, which is this page here, put in your serial number and your registration code, and then register your license, and then that will send you the file. And if you pop it in here and name it reg_ib to go, what that will do, as you can see here, it's defaulted looking for that name to pick it up and find it. The reg_ib Lite file should be there automatically for you anyway, if you're using Rad Studio. So that one's great, but it will pick up and find that and take it off and use it. So that's a quick way to get that deployed in. And that will give you the whole capability of Ib Lite. So you can now go ahead and deploy as you would using PA Server to any platform, and including if you want to test on another Windows machine, you can run directly out using PA Server with your target platform connection set up. If you want to see kind of more details on that, then there's a whole video showing that on the Embarcadero website, so or on the blogs anyway. Okay, so that's a quick setup. I want to show you some of the additional deployment options around deploying database files. So let's just close out of here for the moment. Let's save everything in the group. And I'm going to show you with a sample that I've been using, or a project that I've actually been using. So let's go ahead and open an existing project that I've got. And I want to go into my hoop crew here. So one of the things I do is I'm a basketball referee. I had exams to do, so I wrote a program to store the quizzes to test myself, and also to be able to kind of fetch from third-party API matches that I was assigned to. There's resources like rules and PDFs and match day sheets that I always needed, and it was like all over the place. So I put those in here as well, and I wanted to have a shot clock and a whistle and a horn, and I think that all added into here. So this is a mobile app written using Rad Studio, which is in the iOS and the Google Play stores. The data connection in here, so I have a common data module which has my database connection on it, my physical driver link, and my wait cursor. Now, when the application runs and starts up, it automatically goes ahead and sets the driver to be light if it's not running on Windows. Otherwise, I'm just testing on my development machine locally. So that's a quick option that I've got set there. And then I'll go ahead and set the database connected. I'm using the before database event just to set up the path to the database. So here for iOS and Android, I use the documents path. And I combine that with the database file name. The database file name is a constant I have up here, just hoopcrew.ib. And then that just checks that the database exists and connects to it. So pretty straightforward. Before connection, set my pathing up, connect to the database, and off we go. Now this get documents path, I'm able to use in the project deployment because my database is encrypted and because we've got downloaded personal data, telephone numbers, names, contacts for other referees. I have to encrypt the data to comply with GDPR. So I have encrypted my database on Interbase beforehand, and then I deploy a base copy of that database. So let's have a look here. So we see the database here. And using the deployment, I'm able to add the file in. So I have a folder which is a directory above where this application is, a data folder which I've got a blank copy of the database in. And then for the different platforms here, you can see this is on the Android platforms. I put this in .assets internal, and that then goes to the documents directory. On iOS, if we have a look at the iOS configurations, and we can see here it goes to startup documents. That's the documents directory on mobile for iOS. So using the deployment, I'm able to set up the pathing, push it to the appropriate directory, and then programmatically pick up where it is and connect it up using the get documents path. So pretty straightforward. So that's pretty cool. One of the other things I wanted to show quickly is the admin controls within Interbase that you can use. So if we go to open a sample project here, under the language that you want, so I'm going to have a look at Object Pascal here, under database, under FireDAC, under samples, there's DBMS specific. And in here for Interbase, there's an admin demo. So here, if you open up this provides a data module that you can pick up and use straight away. You can put this direct into your application. It's threaded. You use thread safe connections to run specific tasks. And those tasks back up, restore, validate, mend your database. So here we've got a backup, we've got a restore, validation. We've got a method to see if it's running or not. So this is a useful one to pick up and go. You can see an example of using it within the main form of the sample. And this shows you how to use things like fetching the users on the server and then backing up, restoring, validating, mending the database and so on. So just to show you this in action, you can build something similar for your own application, default username, password, or hide it if you have a fixed one that you use for kind of admin stuff. There's a security key to put in if you're using that. Again, you can embed that into your application if you need to. So for example, let's just go refresh here. I can see the users fetched from IB console, basketball, new username, sysdba. I can see any of the details that set up on them. Nothing's set up on them here, but you can go ahead and set those in there if you want. Backing up, so let's just go ahead and choose a database that I want to back up. So let's back up the employee database and backup path. So let's just back that up to employee IBK. And let's, there's different options here. For example, you can ignore checksums. If you've got a problem with the database, sometimes that could be quite useful. You can back up the metadata only. So if you just want to back up the structure of the database without all the data, you can do a metadata only. No garbage collection, just ignores any kind of data garbage when it's doing the backup, which helps reduce down the size. You can have it non-transportable, which means it will only work on the same platform that it's being backed up on. But let's go ahead, just back up here, and you can see that the UI is running because it's thread safe. It's synchronizing the updates out in here with all the different actions that are running, so you can see, as it goes along what's happening. And then once that's done, just get to the end and stop here. We can see it comes up with the end when it's done. So if we go ahead and look now in the data folder, we can see now we've just got the brand new database that's just been created, or the backup that's been created. And you can see it's quite a bit smaller than the live database, the backup version. Always back up your database and then back up the backup rather than trying to back up the live copy, because unless everybody is out, any reads and writes that are happening on that database file at the time you're trying to back it up could mean that you actually back up a file that is actually corrupted, because what you've backed up has changed partway through being backed up. So always make a backup and back up the backup. To restore, again, similar thing, just go ahead, pick up the restore file, and then give it a name that you want. I'm going to use this new one here. And again, there's things that you can do in terms of validation, making those shadows. If you've got shadow databases set up, you can set it to replace an existing database if it's there. Otherwise, it will error and say, no, I'm not able to, that file already exists. You can deactivate indexes. So if you have any corruption on your indexes for whatever reason, maybe you've been backing up the database file whilst it was running, you can deactivate the indexes and stuff like that. So pretty useful. But again, I won't run that one through, but same thing as before. Validation, again, this is you need to have everybody out of the database to do this, but you can select the database and you can do a validate. That's kind of come back fine there. Okay, so yeah, hopefully that's been a useful introduction to those components and utilities. I say the Data Explorer is very good, even being able to view the data directly inside the IDE as well. So do get familiar with using that when you're working with Interbase. It's a lot quicker to grab the stuff from here sometimes than it is to keep going back and forth to IB console. So there's lots of other components to have a look at within the FIDAC setup. So let's go ahead quickly. You can access stored procedures. There's event handlers for getting alerts back from Interbase when something's happened. You can set up an update SQL as well. Again, for using changes, for setting up different insert, update, and delete statements on data. A lot of different things that you can play with, but they're kind of really outside the scope of this this session today. One thing I want to finish off talking about today is the Interbase VAR program. Now, this is a fantastic way to get into Interbase quickly. You can get dedicated support from a partner manager internally. There's volume license discounting. There's available to you as well. You get direct access into the product management team with special sessions that are run for feedback and discussion, and direct priorities inputs towards the discussions happening around roadmaps and things like that. The silent install option is something that's available to the VAR program as well. We've seen it with the Interbase to Go, being able to run that out, but we can embed and deploy license files that mean that you don't have to manually go and license every version of Interbase for every customer. You can just get your sale, go deploy it, and report back afterwards. Okay, so I think we've got to the end today. Thank you very much for joining us through. Let's open up for some Q&A. There's a question about how easy it is to embed and configure Interbase to install and deploy. We actually had a session covering that relatively recently. I know Shram covered it in one of the webinars that we ran, with quite a detailed kind of look into the installer and how to use it, and to run it through with different license file configurations and so on. But it's pretty straightforward. You just set up the options that you want. You can put them into a file, and then you pass that configuration file to the installer, and it will read that setup and then go ahead and do the installation based on that setup. So it is pretty straightforward to do, which is quite nice because it means that from different installers you can provide different options to the customer, which they can then select, and then you can build your configuration based on that from the installer, and then push that file directly to the Interbase install to run. And you can set it to kind of flag with the dialogues to show, or you can set it to be quiet so it doesn't actually show any dialogues to the customer as well, which is quite nice. So this question is the difference between capabilities for Interbase compared to SQL Lite. Yeah, SQLite is great. It's kind of a bit like a flat file on steroids, though. In terms of the capabilities that Interbase brings, I can't remember if it's stored procedures or triggers, but one of them is not in SQLite. Obviously, Interbase provides both across all platforms, so there are some differences in that kind of form things. Obviously, when it comes to things like change views and embedded user security, these are all features of Interbase that are not available on other database applications that are available on mobile. So there are some pretty cool and fast things there. And also when you start looking at the server side capabilities, things like write-ahead logging and and these kind of configurations for things that are fully ACID compliant and meant for multi-user scenarios, you soon start to see that actually Interbase is quite powerful in the way that it provides the flexibility for a single setup, but all the way through to the kind of the higher end deployments. Yeah, there's a question from also differences between Interbase and Firebird. Obviously, it's an awful long time since Interbase, a fork of Interbase was pushed out to produce Firebird. There's certain things I will say is that the lab tests that have been run
just with some of the capabilities within Interbase, things like the journaling, the write-ahead logging, and all those kind of things make an absolute difference, especially when you start looking at kind of standard warehouse tests. There's some stats up on the Embarcadero pages from the output of those, and it all comes down to kind of load and throughput. You start hitting a critical point with writing to disk, where the hardware then starts becoming an issue if it's not being managed correctly. And that's really where the performance degradations normally come when you start looking at the different database engines. And that's one thing that being able to push as much of it into memory as you can run, Interbase really flies with, and helps it keep pushing way above its its weight in terms of what you think it could do. It really does help it fly. So the more memory you can put in your machine on a server, the more Interbase will happily use, and you can safely use because of the other features that are within the database engines to use that, which is great. So I'll just have a quick look, read a couple of questions here. In terms of databases running on different platforms, Delphi and Interbase will connect up to run on any platform that Delphi targets. In terms of choosing a database for working with Delphi, if you are looking to use macOS or Linux, then obviously you'd need to check to make sure that the database that you want to use there is available. The main thing really is having platform drivers available. The way that FIDAC is set up and configured, it can connect up to the libraries. You just need to make sure that the libraries are there and available for that platform. Have a look at the full list of supported platforms. I don't know for every single database, but they're all on DocWiki. So docwiki.embarcadero.com will be able to kind of give you the pointer to the platform support. Question from Dale about connecting to multiple databases with IB2Go. Yes, you can. There's a limited number of connections, though. So you couldn't connect to kind of 10 databases at the same time because you wouldn't have enough connections within the to-go license. But I think to-go allows you, it's either 4 or 8 concurrent connections to the database in essence. So if you were running kind of a core database and you had a couple of other little databases in there, then that is possible to do with to-go as well. Question about domains. Can you update domains without harming live data? The key thing, if you're making any metadata changes to the database, it's always best to do it when people are out of the database. That said, if you've got a domain and you've got, say, a varchar 20 at the moment and you want to make it a varchar 25, then once you get everybody out of the database, you can just execute that and then run it and off you go. You might be able to do it on the fly. The Ssl compliance will kind of kick in, and anybody who's got an existing snapshot will still see the varchar 20, but then as you come through, it'll go to the varchar 25s. But any posts or updates that you want to apply in would need to match into the new domain structure. So always say the best practice and the least risk is just if you want to make any metadata changes, ask people to come out and then run them back in. One of the things that we used to do on application just to help force that was to put everybody ran the application from the server directly from the file folder, and we just used to put a text file in that we checked for once every 30 seconds on a timer, and if that text file existed, it gave them a warning they're about to be shut down, and then 2 minutes later kind of shut the system down so we could get everybody out. Another option for doing that is if everybody has got a live connection, is to use alerts and to set up like a little table with a single field for system shutdown, true or false, and then if you make a change to it, set an alert that goes through, and then everybody just requeries that table, finds out what the state is, and then can just come out. and that's a very good way to be able to kind of manage that as well. So there's a question here for additional demos. So for RAD Studio, if you come in, you should be able to find this open sample projects, and there's a whole load of demos within there. If you don't have it, tools, manage platforms. Under the additional options, one, you can make sure the developer edition of Interface is installed as a first base point, but also just make sure that the samples are installed with RAD Studio, and that will then provide you with additional samples that you can go and explore. So the examples here, if you go into Object Pascal, multi-device samples, I think there's a few in here somewhere that got Interface, but the data mobile snippets. There's an Interbase one in here somewhere as well. FireDAC Ib Lite. So this one here will give you a complete sample connecting to the database and using it. And you can see different setup and configurations to run. So that's a full sample there to run with. And I'll say the other one's in the FireDAC specific folder, which are a great place to go. Okay, so there's a question here about a connection. Is that to the application or is it to the table? Or so within a basically within a connection, you can have multiple transactions running, and you can have multiple queries running within that transaction. So you could do select staff from employee, select staff from department. You're doing work between them on the client side. There are two queries within the same transaction, within the same connection. So that's a single connection that's running at that point, if that answers the question. Yeah, so the question here also about the previous sessions that are being run. So I'm just close my chat panel. Yeah, bring that back up here. Let me view, show all your. So if you go to youtube.com/Embarcadero TechNet, that will take you through to the Embarcadero list here. And you can look down the playlist for Interface ones. You can also search in the channel here for Interface. But there's a whole load of them in terms of the previous webinars that are being run through. They're all kind of listed in here. So here we can see the one for journaling for disaster recovery in Interface, which was run last month. Again, if you just search Interface in here, you'll find a whole load of them. It's quite a good place to come and have a look. Question about Interface supporting Arabic languages. Yeah, no, that's absolutely fine. Interface is full UTF Unicode compliant, so you can put whatever you want in there, no problems. Okay, just feedback about the question. Yeah, so because I'm live and just by myself, I haven't been able to kind of type all the answers in. Otherwise, you just hear me tapping away on my keyboard all the time. So, okay. Do I need to deploy Interface on desktop, and do I need registration key to deploy it? I will develop on one machine and deploy on another. Do I need 2 licenses? Okay, so in terms of the deployment, we have the developer edition, which you've just seen how to find that in RAD Studio. to install through, or you can go to the Embarcadero, also the interbase.com website, and you can download the developer edition from there for free. The developer edition you can run on your machine for free. It just needs to be restarted every 48 hours. It includes the standard encryption, not the strong encryption, so just the DES encryption. If you want to deploy out onto another machine, then you will just license that machine for Interbase. The Interbase license includes the hot backup machine. So if you have a disaster recovery failover machine, the license covers that machine as well. You don't need to have a separate license for that, which you would do for things like SQL Server and so on. The development machine, obviously, if you wanted to have the strong encryption on there, then you would just need, a desktop license would be the cheapest way to kind of get there. But if you're part of the OEM VAR agreement program and you're deploying lots of licenses, then they're typically covered as part of the VAR contract as well. Okay, so final question about how to register the license. So yeah, to register the license, you just need to open up the license manager. If you open up IB console, tools, license manager. In here, you just need to go ahead and register. So if you just click the register button here, you can put in your serial number, your EDN account details and register, and that's as much as you need to do. That's all you need to do. But I hope that kind of helps the questions. If I have missed any question, then please feel free to email me through. Yeah, okay. Sorry, there's one last question here. It was just about deployment, which I was just trying to read and get my head around. So Bruce was just asking about Xcopy install. Yeah, basically, if you're going to build and deploy, the easiest way to do that from Rad Studio is actually to install PA Server. Under the program files, Embarcadero, Studio 21, PA Server, you can here find the PA Server setup for Windows. Now, if you install that and set up your configuration to point, you can set your target machine here to add a new profile and point it to a local loopback and run PA Server via command line on your local machine. Once you've done the deployment setup and configuration for the project, if you just come in here and hit deploy, what that will do is it will deploy all the files and everything into the correct folder structure under your PA Server Scratch directory. And you can just go to that folder location and everything you need, you can then just Xcopy and move from one machine to the other. So that's as simple as it gets in terms of being able to move and deploy out. So yeah, PA Server is the key if you want to use the Xcopy distribution, Bruce. Okay, hopefully I say that's all the kind of the key questions answered as we've been going through today. If you do have any questions, then please feel free just to drop me an email over. So my email's there on screen at the moment. Thank you for the questions. There have been some really interesting ones that have come through today, and happy coding, and look forward to kind of catching up with you on a webinar sometime soon. Take care, everyone. Bye-bye.
Hello, and welcome to my webinar on journaling for disaster recovery in Interbase. My name is Mary Kelly, and I am a software consultant / Interbase enthusiast here at Embarcadero. I really enjoy answering questions relating to Interbase and the rest of the Embarcadero tools, so please reach out to me if you have any comments or questions at mary.kelly@embarcadero.com. On our agenda today, we're going to cover disaster recovery in Interbase and how to implement journals and journal archiving to keep your database safe when tragedy hits. We'll go over some tips for journaling and journal archiving with Interbase before jumping into our Q&A. Now, we all know that Interbase is a great database for a wide variety of industries. With its small footprint and its ability to be this powerful and reliable database that runs in a lot of different scenarios, we don't really think much about what happens when there are failures in our systems, whether it be hardware or software failure, a massive power outage or surge, a corruption in a database, or even external threats like malware. You need to have that plan in place to figure out how and what process you'll take to deal with that failure. We all have some understanding of what a disaster recovery plan actually is, but to reiterate, it's the belt of tools and procedures that you and your organization use to recover from a major disruption of your typical or normal operations. The plans themselves will be specific to your organization or industry's requirements for preventing data loss, so I can't really tell you the steps you need to follow, but there are some questions that you can ask yourself to figure out how to best configure your Interbase server for journaling and subsequently journal archiving. Now, DR plans often incorporate a lot of data specifics, such as recovery points, how long it will take to recover your normal operations, and things like making sure that the location for offsite backups or even the secondary physical server location is available and up and running at a moment's notice. But to really get an idea on the answers to these questions, you kind of need to know what the questions are in the first place. So things like, what is the requirement for recovery time? Because we all know that every second counts. When your system fails, again, whether it be a hardware, software issue, it could be a cyber attack, it could have a devastating impact on your organization. And in the digital world, as we know it today, those failures could lead to a supply chain operation imbalance and could financially impact your organization. So every second of that disruption or not knowing how long it could take to fix will count. Questions like, how often should I back up my database? Or do I have other options available to me? Is a backup good enough for DR? Or do I need some other software out there? There are options that go beyond a backup and restore with journaling and journal archiving. For instance, you can archive an operational database that has a log of sorts of all the transactions in the database so that you can recover your system's data. How often should you review your disaster recovery plan or change it? And what kind of technology are you using in your disaster recovery plan? And is it efficient enough to prevent data loss and safeguard you from different kinds of disasters? So moving on to some of the options that you have available in Interbase for disaster recovery. With Interbase, we offer a hot backup or standby server that you can install and just leave off until the time you need to start the server up in the event that your server gets destroyed or gets taken offline for any reason. And with that, we also give you journaling and journal archiving. First, let's take a look at what journaling is and how to set up your journals before seeing how journal archiving can assist you in your recovery efforts. A journal consists of one or more journal files. Now, a journal file records each database transaction as it occurs. This makes a journal kind of an always up-to-date record of your database transactions. So journaling is also sometimes referred to as write-ahead logging, and it provides the security of immediately writing changes to disk with the benefits of a full in-memory database system. Journaling can be enabled on a database through a single line of SQL and requires no changes in your application to have it enabled. So how does this work exactly? Journaling turns off forced writes to the hard drive and synchronously writes the updates to the journal file instead in a sequential pattern, which allows for an improvement in your database's performance. You set up these checkpoints to automatically occur to save any changed pages in the database cache directly to your hard disk. These checkpoints specify the time at which Interbase must save all of those changed pages in the database cache to the database file. Now, journaling guarantees that all changes are on disk before a transaction is actually marked as committed, as long as the OS and hardware caching are disabled. While you don't necessarily need to use journal archiving to use journaling, it is recommended, as journal archiving lets you recover from a disaster that completely destroys the database server. To create a journal file and activate journaling, you're going to have to use the following DDL syntax that's listed here on the page. There are several parameters that you can also use, and we'll take a quick look at them. You'll create the journal with the journal name specification. So this is just going to be the full path and kind of base file name of the journal file. Now, if you don't specify the location for the journal file, then it's actually going to create the journals in the same folder as the database itself. So if you want to have some kind of separation, I recommend that you have a subfolder in the folder that holds the database file so that you can write within that folder. You have length, and this clause specifies the number of pages that can be written to the journal file before it has to roll over into a new journal file. Now, I think the default for this is about 4,000 pages, which
we're going to quickly sidestep into determining journal rollover frequency. So determining the most effective rollover frequency is going to be more important for a lot of use cases, and it's going to be different based on your specific Interbase installation. So this result will be placed as the length clause of the create journal statement. To determine the frequency in bytes, you're going to take the journal file length, multiply that by the journal page size, and that's going to equal the number of bytes before the rollover can occur. Then you can also determine the rollover interval by taking the page length, the journal file length times the journal page size, and then divide that by the journal page size times the number of writes per minute, and that's going to be the number of minutes between your rollovers. And then beyond that, if you need to calculate the journal length to give you the rollover interval, you can specify the rollover interval that you just calculated, multiply that by the database page size and the writes per minute, divide that by the journal page size, and that will give you your journal file length.
Checkpoint length, this is going to specify the number of pages that you can write to the journal file before a checkpoint occurs. The checkpoint interval, and this is going to determine the number of seconds between those checkpoints. If you have both a interval and a length for the checkpoints specified, whichever one occurs first is going to be initiated by the database checkpoint. And then page size, page cache determines the size of a journal page in bytes. Cache determines the number of pages that are cached to memory. So the default is around 100 buffers for the page cache, and the page size can be up to approximately twice the database page size. You can also choose to specify a timestamp name, and this will determine whether or not you want to append the file creation timestamp, or if you want to go for the default, which is the year, month, date, hour, minutes, seconds, and then the sequence number .journal. And pre-allocate just allows you to specify the disk space allocated for those journal files. Now let's take a quick look at how to create the journals and actually see what this looks like.
From IB Console, I'm currently connected to the DR Journals database that I've created. I can right-click on that database and go to Backup and Restore options, where all the way at the bottom I've got Create Journal. You can then specify all the options relating to your journal file that you want from here, and you can then go and create the journals. Now the journals will automatically populate into your folder where your database is listed unless you specify otherwise. So now that those files are there, we can see how to create them in iSQL. We'll drop this journal, and then from IB Console you can create journal, and of course specify the options available that you need, and the files get automatically created from there. You can then go through and drop the journal under any circumstances that you need. Now let's take a look back at what you can do with journals and journal archiving next.
A journal archive is a directory that contains a full database dump and all of the journal files that have been completed since that dump. You can use the journal archive to then recover to the last transaction that's been recorded in the most recently archived journal file. Now you can use the archived journal files to perform point-in-time recovery, and this point-in-time recovery uses that timestamp internally that's recorded on each of the transactions in the file, which allows you, if you so desire to recover to that specific date and time. Now, the purpose of journal archiving is to provide you with a more effective and efficient disaster recovery process, and as such, it enables you to recover to the last committed transaction in the most recently archived and completed journal file. So the best part about journal archiving, though, is that for disaster recovery purposes, the journal archive can be located on a different machine, ideally in a remote location than the one that houses the database server, and doesn't require that you have a server on that remote machine. So you can have a dedicated system that holds all of those journal archives completely separate from any machine that has Interbase installed, meaning they're always away from the server in the event of a potential crash and can let you bring a database back online with that point-in-time recovery. This also means that the up-to-moment recovery is actually possible if the hard drive where Interbase is installed that contains the current active unarchived journal file is actually still intact. Now, since only completed journal files are actually added to the archive directory on the remote machine, there is a potential downside, which is why we have to look at those checkpoints that we mentioned with journaling. Now, if a disaster wipes out the hard drive that contains an active, incomplete journal file, the data on that file or on that disk will be lost, which brings us to those questions that we asked earlier about how much time can you afford to lose. This will help to determine the checkpoints and the journal rollover frequency as well.
To set up your configuration for journals and journal archiving, you can kind of use this criteria to help you determine the optimal configuration for your system. So that's going to include things like the I/O speed of the device where your journal files are being created. So this is going to be the server itself. The speed of the concurrent creation of new journal files. Also the hardware requirements and the ease of setup for it as well. Now, one benefit is it's not necessary for Interbase to be installed and running on the machine that's being used for that journal archive storage. It can be a bonus, but it is not a necessity. Journal archives are also platform specific. So for example, if you create an archive with Interbase for Windows, it cannot be directly used to recover an Interbase database on another platform. Instead, you would use the archived database dump to back up the database in a transportable format, and then you would restore that database on another platform. Now, there is a slight limitation. The number of items allowed to be archived will be limited by the number of files that are actually allowed in a directory for your given file system. For journal archiving, I created a folder called archive, which is where my journal archives will be held. Now, under normal circumstances, I would move this off my machine to some remote location, but in this case, for demo purposes, I will keep it on my machine. Now I can go right-click, go to Backup Restore, and create the journal archive, where it's already opened up to the path of the database, but I'll go ahead and expand that out to include the archive folder. Okay, and I'll also choose to archive the database. Now I can click OK. The archive has been completed, and the database has also been added to the archive. You can click OK on that. And now going into that archive folder, I can now see the database archive as well as the journal has also been included there. Now, one of my recommendations is to actually just go through the command and create a series of batch scripts so that you can create your journals and also create the journal archives and set a lot of the specific options, such as the dump count, so the number of journals that are allowed to be kept in each archive directory. You can use that with a gfix. And then also you can archive the entire database and archive those journals as well. You can set it up using the Windows Task Scheduler, and that will allow you to automate the process of those backups for your journal archiving.
So disaster strikes, the worst has happened, and your system's failed from some force. So what do you do? Well, you start off with your plans step by step until you get to data recovery.
Now, taking a look at what this looks like to recover the archived data dumps to the new destination database. Now, this could either be the database on the same machine if it's a software database corruption, or it could be a brand new machine set at a secondary location, either that standby backup database server or a brand new server. And you'll want to run a gback and then archive recover. You can use the until timestamp switch. Now, if you don't use this switch, the database is going to recover or attempt to recover and apply as many journal files that are possible to recover the database to the most recent point in time. So if it's possible, the database is going to attempt to recover files by jumping from the archive directory to the local journal directory to apply the journal files that haven't been copied to that archive. Now again, that is specifically to a software database corruption rather than a hardware issue. So in that situation, it's even possible under some circumstances where the database can be recovered to the most recently committed transaction of the original database, allowing for even less data loss. You'll then add the archive database name as well as the new or recovered database name as well, before then setting the database to active for read and write transactions. So it will only be listed as a read only, so a gfix setting the mode to rewrite of that recovered database name will then let you activate that database for write permissions. Now at this point, your database will not have any journals or journal archives listed anymore, so you'll want to start that process by setting it up again. You can create, again, that batch script that sets up the journaling, create journal archive, and then run that after a disaster recovery is successful.
Moving on to some tips and best practices for journaling and journal archiving. So the first tip I can tell you is to start building a new archive as soon as you have had a successful recovery of your database. You can create the new archive by issuing the gback archive database and archive journals commands, and this will start the process all over for you. Now, determining journal rollover frequency. Journal rollover frequency is a pretty time-consuming process. So if the rollover is happening too quickly, then performance can degrade over time. But if you're using journal archiving, then you kind of want those journals to roll over as often as possible so that you can complete the journal to be sent over for archival purposes, which would reduce the number of transactions that you'd actually lose during a disruption if it essentially destroys the server. I can tell you it's a bit of a balancing act to determine what's going to be best for your installation, but you can use those 3 equations that we mentioned earlier to figure out what might be the best value for you to use. Determining your checkpoint intervals. Now, if you recall, Interbase uses those checkpoint intervals to see how long it takes for Interbase to recover after a server crash. Now, say your server crashes, all of the changes that were in the cache are now lost. With journaling, remember, all of those changes were written synchronously to the journal. So they're not actually lost on disk, they're just lost to the database. So when the database restarts, it has to read through all of those journal files and copy those changes in the journal to a newly restarted database so it can get back on track. The more journal files you have, the longer it takes to restore. So figuring out what that checkpoint value is for your system is going to be a major bonus in getting you up and running in the most realistic time frame. Making sure that you pre-allocate journal space, and this is for kind of a best performance that you can get. Journal files should always be placed on a dedicated hard drive. And using this pre-allocate clause enables you to allocate space that's equal to the maximum number of journal files that will exist on your machine during normal operations. So this is also particularly useful if you don't have a dedicated drive, as this will actually guarantee that other files on the machine cannot use or consume the space that would be needed for those journals. One extra tip is to add in some extra space on top of that so that any journals that lose connection to your dedicated remote disk for archival can all be archived after the connection is gained back. And of course, the last tip I can give you is to practice your recoveries. Now, this is something probably everyone here has already thought about, but it tends to be the most important aspect to have down. Practice makes perfect, and testing or validation processes on your database recovery before a disaster can take place takes a lot of the guesswork out of how long it's going to take and what systems and what practices need to be followed to give you the most efficient plan for your business. Thank you again for joining this webinar on journaling for disaster recovery in Interbase. Now let's move into the Q&A.
Hello, my name is Carrie Jensen, and welcome to Code Rage 2018. This session is Persisting FireDAC Datasets to There and Back. Let me share some information about me. I'm Chief Technology Officer at Jensen Data Systems with more than 30 years of experience as a developer, consultant, trainer, and mentor. I've written more than 25 books on software, including my latest book, Delphi In-Depth FireDAC. I specialize in database development, application architecture, and component development, and I'm an Embarcadero MVP. I also have a PhD in engineering psychology from Rice University in Houston, Texas. You'll see here on this page also my contact information. Here are the topics I'm going to cover in this session. I'll begin with a broad overview of FireDAC. Then I'll discuss what do I mean by persistence. Next, we'll look at persistence in FireDAC, including saving to files and saving to streams. I'll also discuss what can be saved when we persist data. Next, we'll look at restoring previously persisted data, including the merging of data. Finally, I'll conclude with automatic persistence and how that can be used to create backups. FireDAC is a comprehensive, component-based data access framework available in Delphi. It represents the most complete support for the T-Dataset API, the application programming interface for data access in Delphi. FireDAC supports a large set of database servers and data formats, and it provides a smooth migration path for legacy applications, particularly those that were based on the Borland database engine. In all, FireDAC supports an unmatched collection of capabilities. It has become the preferred data access framework for data access in Delphi. So what is persistence? Persistence refers to the ability to save data at one point in time, preserving the opportunity to restore that data to its original state at some later point in time. This data can be saved to a physical file, or it can be saved to a stream. When it's saved to a stream, that stream can be transmitted over a network, or even saved in a blob field of a database. Upon restoration, the restored data may be indistinguishable from that which was originally saved. In FireDAC, persistence is a capability of all FireDAC datasets. Prior to FireDAC, only the client dataset could be used to persist data. But with FireDAC, your FD queries, FD stored procedures, and FD tables can be persisted as well. It's not just a feature of the FD mem tables, although FD mem tables do support persistence. Because the datasets in FireDAC support persistence, this greatly decreases the need for FD mem tables. Of course, FD mem tables have their own set of capabilities that are very valuable, and you may want to use them in your application, but you don't have to use them just because you want to have persistence. Let's consider saving to files. With a FireDAC dataset, you save to a file by calling the save to file method. That method takes 0, 1, or 2 parameters. The first parameter is the file name. Now this is interesting because the file name can include some very specific substitution variables in the file name, including $doc, $temp, $run, $rand, and $next. These substitution variables get expanded prior to saving the file. $doc represents the documents folder in your Windows installation. $temp is a temporary directory and expands to that folder. $run represents the directory in which your executable is stored. $rand is a random integer as a string. And $next is used to generate the next integer in a sequence. And you can use these substitution variables in various parts of the file name. So for example, if you want to store the file in the directory where your execution is stored, you would begin your file name with $run, and then follow it with a slash and then the name of the file. That file could include something to the order of backup $next. Of course, after the $next, you would include a dot and a file extension. Although you can omit that in various scenarios, and I'll talk about those a little bit later. In addition to these 5 substitution variables, you can also include your own environment variables in the file name. And you do that by doing $open paren and then the name of the environment variable. And that environment variable may be a string or it could be a folder path. If you call save to file with no parameters, then you must have defined the persistent file name in your resource options. And we'll come back to that later when we talk about automatic persistence. If you do include a file name, you have the option of including a second parameter, which is the supported file format. Specifically, one of the values of TFD stands storage, which is a set. And those include SFXML, FSJSON, FSBinary, and FSAuto. Of course, this is how you can specify that you want a particular file format saved. XML clearly will create an XML file, JSON will create a JSON file, and binary will create a file that is specific to FireDAC. Finally, there is a Save Pretty option. In the resource options for your FireDAC dataset, there is a property called Save Pretty Print. And if you set that to true and you are using an XML or JSON format, FireDAC is going to format the data to be more human readable. It'll put lots of carriage returns in and it'll use indentation to make the text very, very readable. So let's go ahead and take a look at this. I have an example project that you can download. It is called FireDAC Save and Load, or FD Save and Load. Now this has, I have a couple data sets here. These are FD tables that contain customer data and employee data, and I'm using local SQL to query them. So here's an example of a query. I have a little note up here. There are only 2 tables available to query in this database. And let's go ahead and run this project. And we'll run the query, and when I call save to file, I'm going to be saving the file from this result set here. And when I say save to file, I'll go ahead and specify. Okay, let's go over to Code Rage and persisting data and save and load. And here I'm going to enter CA customers for California customers .xml, and we'll save this as XML. Let's go ahead and take a look at that file that we just created. And here, Code Rage. And CA customers XML, and I'm going to open this with Notepad. Otherwise, if I opened it in Internet Explorer would format it for me, and I don't want that. I want to show what it looks like. So this is not a very human readable form, but it is terse. It doesn't have the extra carriage returns, and it is in fact valid XML. Let's save this again, but let's enable the pretty print capability. And we got this CA customers. I don't need all of that, but I will say I'll call this CA customers pretty. And now we'll go down and look at CA customers pretty. And we'll see that it's formatted. Let me turn off the word wrap, and we get a nice, much more human-friendly format of this data. Let's try the JSON. This time I will leave pretty print on, save to file, and we'll say CA pretty, except I'll change the extension to JSON, and we'll go and look at this. CA pretty JSON. Oh, open with. Okay, I guess I haven't opened on this particular one. I haven't opened up JSON yet, and Word. Well, I'll use WordPad, and I'm disappointed it's not letting me do this in Notepad. Okay, and there we have it. There's our JSON for all those records that were stored there. Okay, so let's just take a look at this code. It's here. Okay, we open a save file dialog box, and we're in this case I'm actually using two parameters. The file name I've selected, and I'm using specifically specifying fsxml. If I used fsauto, I'm pretty certain I would have gotten exactly the same results because of the file extension I used, but in this case I was being very explicit about it. If we look at the code associated with the checkbox on save using pretty print, you'll see that I'm just really toggling the store pretty print of the FD query's resource options. The resource options of the FireDAC query allow me to set the resource options directly for that FireDAC query. Alternatively, I could have set that store pretty print resource option for the connection that this FireDAC query used, and any other query that also used that same connection would be storing pretty print as well. On the other hand, I could have even gone one level up and set the store pretty print property of the file FD manager, and then all connections and all queries and stored procedures and tables would by default store pretty print, although you can override those on specific FD tables or FD queries by going into their resource options and changing their store pretty print parameter. I will show you an example later on of using substitution variables, so we will come back to that. Saving to streams. You save to a stream by calling save to stream, and when you do so you pass either one or two parameters. The first parameter is a tstream, and in my example I'm going to use a tmemory stream. If you want to include the second parameter, you're including a value of the type tfd storage format, and again this allows you to specify specifically the storage format that you want to store that stream in. You could just simply use auto. I found in a couple situations that I want to explicitly store it in a given format, and then when I load it again later I want to tell it it's this format. So let's go ahead and look at Delphi and see what this looks like. So I've got that application running. Now this is not so very visual when I save to a stream, because I'm going to do something that I find very useful. I had mentioned in the slide that when we save to a stream, we can then take that stream and transmit it across the internet, but we can also save it into a blob field in a database. And in this particular case, I'm going to do just that. However, this is a temporary database that's created every time I run this application, because I am using the FD local SQL. So I'm using SQL based on the Ssl Lite definition of SQL. And that is we see we have a SQLite FD connection component here. And so notice what I do when I click Save to Stream. I am actually asking for a dataset name, and that's really going to be the name that I'm going to store this file under, actually the stream under, within my database. And so what I do here is I first call fd query save to stream, and I'm saving it to a memory stream that I create here. And I'm saving it in XML format, rewinding the memory stream to position 0, and then I am opening a query selecting all the data sets from our database that we're connected to, which is basically a virtual database in memory. And then as long as I have data in my query, I'm taking the database name that was entered in that input query, and I'm assigning it to the first field. And then I'm loading the second field, which is a blob field, from that stream. And that's how I get the data in there. Now you may be wondering, where did this data table come from? And we'll see that over on the form create. When the form starts, I start a transaction and create a table called data store tab, but that's the constant. It's actually called stored data sets or stored data sets. And I do that, and then I set some settings. But the most important thing is that database that I'm writing to, and that particular table I'm writing to, is created when this form is initially loaded. And then just to remind you, we're then selecting records from that data set. And I could have actually done this slightly differently. What I could have done was to create an insert query. But in the way I did this here, by opening a FireDAC query with all of the records, I then could call append, which added an additional record, and then I'm loading the data into that record and posting it. What gets persisted? Well, the really cool thing about this is that you get to choose what gets persisted. You can choose to persist one or more of these following characteristics. You can choose to persist the data that's stored in the FireDAC dataset. If you've been using cached updates, you can also store the changelog, or you can suppress the changelog. You get to choose whether you store the metadata or not. And the metadata is a description of the structure of the table that you're storing. This last one is kind of an odd one. You get to choose whether or not to store the visible records, and that is there is a property in FD datasets called filter changes, and you can set it to include unmodified records, modified records, inserted records, and deleted records. And visible records is going to base the records that it stores on that filter changes property of your data set. So for instance, and this is pretty interesting, I could filter my FD dataset on my deleted records. This assumes that I'm in a cached update mode and have captured deletions and cached them. Then I could say I want to store the visible records, and I could actually store off a set of the records that were deleted so that at some later time I could go retrieve them if that was something that I needed to do. So let's go ahead and look at the, I'll just bring up Delphi here so that the whole project is available. Go and look at what I've implemented here. So for the save options, I've allowed you to checkbox data, delta, metadata, and physical. And let's look at the data and look at the click event handler there. And it's basically saying, look, if you have checked this, then we're going to make sure that the SI data flag is in the resource options store items property. If it's not checked, then we remove the SI data. And the same thing is true for the others. So the data, the delta, the metadata, and the visible. The default property for the store items is SA data, SA delta, and SI metadata, which means that you're going to store all the information you have about the data, the current state of the data, and if cached updates were used and you have a changelog for the FireDAC dataset, it's also going to store the changelog as well. So let me demonstrate this. Now, in order to do this properly, if we want to see the metadata, if we want to see delta, we have to be in a cached updates mode. So I have this data set here, and I'll enable cached updates. And let's go ahead and delete a couple records. I'm going to change American Scuba Supply to American Scuba Company, and let's go ahead and add a record too. We'll call this Carrie's Dive School and post that. And so let's go ahead. I have data, delta, and metadata. Oh, and let's turn pretty print on just so that it. Okay, let's save the file and file name. Let's just do file name test.xml, and let's go ahead and look at it. Okay, so here's our metadata there, and here is our data, and notice it has identified 2 deleted records, and here is a modified record. Here's the original and there's the current, and then down here we have an inserted record. So this inserted, modified, and deleted, that's able to restore the cached updates information. This information here is used to identify the metadata, the structure of the file, and of course all the original values are the values that will be present if we cancel the cached updates. Let's go back and see how this can be used. So let's close that. Let me rerun the query against the data set. Oh, let's say, oh, it doesn't matter. I think I just run that query. No, it says that it's been, so I have to cancel updates. I will rerun the query, and there's our data. Now let's load from file, and we'll load up the text.xml, and now notice we are in updates, and notice that there is cached updates there. The 2 records that were deleted are there. The change that we made and the addition that we made is here, and this is actually in a cached update state. If I press apply updates, that data will be written down to my database file. Frankly, I don't want to do that right now, but in a lot of cases when you're doing persistence, that's exactly what you want to do. You're persisting data off. Maybe you're using a briefcase model of your application. Every time you persist, if you're in cached updates, you want that delta information to be stored in the persisted file. This will allow a user to make some changes over multiple sessions. Possibly they have retrieved data from a database server, but then gone out into the field where there's no wireless connection, or there's no ability to connect via mobile phone, and they make a bunch of changes but close the application and open it, close it, open it, and make multiple changes over multiple sessions. Now they're back at the office. They load up again, and it's got all these cached updates. You're able to connect to your database, and here you're doing the apply updates. So really nice feature. All right, let's continue now. Restoring persisted data. You restore persisted data by calling load from file or load from stream, depending on how you persisted the file. When you call load from file, you can provide 0, 1, or 2 parameters. If you have no parameters, then it's resource option settings that are going to control what file gets loaded and what format is being loaded. If you provide 1 parameter, you're specifying the file name. And that file name can use those substitution variables that I introduced earlier. If you provide 3 parameters, you're providing, if you provide 2 parameters, you're providing the file name and the file format that you are instructing FireDAC to restore from. Loads from stream is very similar. You provide a call to load from stream, and you provide it the stream in which the contents is provided, and you have an optional second parameter which will be the file format. And in the work I've done, I've often found that, and I mentioned this earlier, that when I save to a stream, I will save to a specific file format, and I'll specify that same file format when I load from that stream. Now here's the really, really cool and rather complicated, interesting bit about loading data into a data set from a persisted file or a persisted stream. You can merge data from more than one file or more than one stream. Now that might sound very unusual because if you're a longtime Delphi guy like me, you're familiar with load from file in a client data set. And when you do load from file, if that client data set already has data in it, it's going to be purged first, and then the new data will replace whatever was in there. But with FireDAC, you can do some really interesting things because you can have data in a FireDAC data set and then call load from file and bring data in that doesn't necessarily replace what's already in there. It can add to it. That is done through the store merge data property of the resource options associated with your FireDAC dataset. And store merge data is of type TFD merge data mode, and it includes 7 different settings. When store merge meta is set to DM none, the default, no merging takes place, and the FireDAC dataset is loaded with the contents of the file or stream. The remaining 6 possible values of store merge metadata are organized into 2 sets of 3, with one set applying to the data and the second set applying to the change cache. Let's consider the set that applies to data first, and these values are DM dataset, DM data append, and DM data merge. For these values, the data that is being loaded will either replace the data in the active dataset, as in DM dataset, be added to the dataset in the active dataset, DM data append, or be merged with the data in the active dataset. For the set of values associated with the change cache, delta, essentially the same rules apply. When store merge data is set to DM delta set, any data and change cache information in the active dataset is replaced by any data and change cache information being loaded. A value of DM delta append causes any data and change cache information being loaded that is not already in the active dataset to be added to the active dataset's data and change cache. Finally, merge will either update or append the data and change cache of the active dataset based on the data and change cache that is being loaded. With the resource options store merge meta, this controls how metadata is merged in when you have an active data set and you're moving data into it from another file or stream. When store meta merge is set to none, the dataset returns its original metadata regardless of the contents of the data being loaded. If the structures of the dataset and that of the file being loaded match, everything's fine. If there are discrepancies, data will be loaded into the dataset using the rules defined by store merge data, only for those fields in the structures that match. For example, if the active dataset includes string fields named first and second, and the data being loaded defines fields named first and last, data will only be loaded into the dataset's first field. When storage merge meta is set to none, it is necessary that the FireDAC dataset into which the data is being loaded has metadata, or that its potential metadata can be discovered. When store merge meta is set to merge, columns from the dataset being loaded will update the dataset doing the loading. When matching column names are found, any differences in those columns' type and size will be updated in the loading dataset to match those of the values in the dataset being loaded. If columns are found in the dataset being loaded that do not match those in the dataset doing the loading, those columns are added. If store merge meta is set to add, any column found in the dataset being loaded that is not already present in the dataset doing the loading will be added. Columns with the same names are unaffected in the dataset doing the loading. Assigning update to the store merge meta property will result in matching column names being updated in the dataset doing the loading, based on the metadata found in the dataset being loaded. Column names found in the dataset being loaded that are not present in the dataset doing the loading are ignored. When store merge meta is set to add or error, one of two things will happen. If the dataset doing the loading has no metadata, the metadata found in the dataset being loaded will be used. If the dataset doing the loading has metadata, it must match that of the dataset being loaded by name, type, and size. Otherwise, an exception is raised. The final store merge meta value, error, requires that the dataset doing the loading has metadata, and that it matches the metadata of the dataset being loaded. If there is a mismatch on column names, types, or sizes, an exception is raised. Clearly, these are complicated settings. What you can do in Delphi, if you want to play with this, a reasonable thing to do, I'm going to hit cancel updates here, and let's go ahead and just one more time I'm going to save this to a file, and I'll say this is CA Rex for California records.xml, and now I'll run the query, and this time I'll select customers from Hawaii, where it's HI is the abbreviation. Run query, and I will say saved file, and instead of CA Rex I'll say HI Rex. And now I'm going to say that I want to store merge data, and I'm going to append, and I'm going to load from file, and I'll get the HI Rex, and that data gets loaded in. If you have different columns of the data you select in your query, or you do some changes and apply those changes so that you have key fields, which is the customer number, but some of the data is different, you can test out how the store merge data works. If you have different numbers of columns, you can play with the store merge meta, and this allows you to really investigate the finer features of this particular these particular features. Okay, now this takes us to the final topic, which is automatic persistence. Now this is a very, very cool thing, and it really applies in two specific scenarios. First of all, if you want to build an application that has relatively simple data management needs, it just needs to be able to save to a file, and then when you start up the application, load from that file and keep the data over an extended period of time, but storing it in a file instead of a database, for example, in a simple address book type application, you can configure FireDAC so that when you open your data set, it loads with data, and when you close the application, it saves the data. And you don't need to use code. The operation occurs in the background automatically for you. The second application of this is the ability to create a backup file so that users can make some changes and save and close their application, and after they've made changes to their data, a backup is created. So you always have at least the image of what the data looked like the last time it was edited. And you can get pretty sophisticated with this by using the $next substitution variable, and then you can create multiple backups. For instance, you'd have the backup 1, backup 2, backup 3, backup 4, with the higher number always being the most current backup. Now you have to be careful there because you're storing multiple files, and after a while you're going to have more backups than you want or need, so you're going to have to build some additional logic into your application to ensure that you're only keeping so many backups. Nonetheless, this can all happen, and it happens through the use of resource options. Now, I referred to resource options multiple times, but there's actually two resource options classes that you have. In the FD Connection and FD Manager classes, their resource options type is FD Top Resource Options. In the individual FireDAC datasets, such as FD-query and FD-table and FD-memtable, the resource options property is type FD-bottom resource options. What this really means is to really take control over these features and these examples that I've used of the having a automatically loading and saving file format, or having the backups being created. You're going to use a combination of the FD datasets resource options and its the object that it inherits from, the FD connection or FD manager. If you're creating backup files, you would specify the folder and the file extension, the default folder and file extension for that backup file using the FD connection or FD manager. You then, if you are using a persistent file in which you are automatically loading and saving a file, then you would specify in the FD connection or FD manager the default store folder. Anytime we're talking about folders, you can use variables. So the backup folder, I didn't put that here, but you can use variables there. And I'm talking about the substitution variables and the environment variables. If you're creating a backup, then you set the backup resource option to true, and that's in your FireDAC dataset. The default store extension is also in the default dataset. Persistent means that you want to automatically load and save a file. That's a Boolean property, and you set it to true if you want to persist your file. And then the persistent file name is the name of the file that you want to write to within the default store folder. And that file name, if you don't have default store folder, you can actually put a full file name there. And again, persistent file name can use variables. The load from file at open and save to file at close are functions that you can use to programmatically determine whether automatic loading and saving is occurring. And so it's not something you set, it's something you read, and that'll allow you to determine how things are being done. So let's go back over to Delphi, and I'm going to open up the next example project. The final example in this session, in fact. And I'm going to open up, okay, so this is the auto load backup. Now I'm using a FireDAC memtable in this particular example. The interesting thing about FireDAC memtables is it's the one data set that doesn't have an FD connection. Because clearly there's no connection to a database associated with the FireDAC memtable. In that case, if I want to work with FD top resource options, I have to work with the FireDAC manager, FD manager. Now there's a default one. This is a singleton object, and you can only have one. And if you don't actually place an FD manager into your project, one is created for you. And that's the thing that's the version of the FD manager I'm going to manipulate in my on create code here. So let's look at that code. And here we go. In the form create, I'm setting the backup folder to the executable directory and then a directory called backup under it. And I said I want the backup to have an extension called back. Now here's an interesting thing. That backup folder, I'd like to know what exactly that folder is. So I'm calling the backup folder, I'm calling the FD expand string function of FireDAC to take that backup folder and expand it to the actual physical file location. So what that'll do is cause the substitution variable to be expanded to whatever it refers to. And I'm asking if that backup folder doesn't exist, then I'm going to force the creation of that backup folder. Furthermore, I'm saying that the default store folder is also the run folder, not the run backup folder, and the default store format is the store format of XML. That I want backups to be created, I use the FD memtable's FD bottom resource options and set backup to true, the persistent file name to clients.xml, and persistent I set to true, and that'll create the automatic creation and destruction. Now what I'm doing here is I'm saying, hey, if that persistent file name does not exist, then I'm going to create the structure, the initial structure of the FDMEM table. And I finalize that by calling create dataset and then opening the dataset. Actually, create dataset opens the dataset. Opening the dataset is what I call to open the dataset, and that will open up clients.xml in this case because the file obviously exists. So let's take a quick peek at the directory so we can see that before we start a directory for this project, and I'll show you that initially we have no backup folder and there's no clients.xml project. So come back over here, let's run this project. When the project runs, it's going to open this data set that's created for the first time. We go over here, notice no clients because it's not going to be created until we actually save. So let's add some data, and I'll create a couple names here and a couple. I'm not going to fill out the rest of this stuff. Now I'm going to close this, and there's the client XML that's just been created. Notice if we go into the backup directory, there's nothing backed up yet. And I did force that directory. I created that directory when this ran. Now, in code by doing the, where is it, right here, directories, just force directories, that's where I created it. Let's go ahead and run again. In this case, it's not going to create the file, it's going to open it. And it does it automatically. Well, there's the file there. I called open and it went and loaded that file. Let me make a change to this. We'll add another record. Let's even make it more interesting. I'll delete this second record. Now I'm going to close, and if we go to the backup directory, clients.back, so it actually persisted a previous view of that record, or that data set, a previous image of that data set. And I've got a button here that'll go to that data set and show me what I have. That was before I edited and added Carl and removed Bob. That is my backup. And this is the current version of the file. So this is a fun little thing. There's precious little data in here, or code. Showing backup has the code that just says, okay, let's go and open up another form and load data from that backup file. And this here, I'm just, when the form is closing, if I have any data that is currently hasn't been posted, I'm going to post it before we close. And there, that's something to play with. Thank you for joining my session today. On this slide, you'll find the URL for my website and my email address, as well as my blog and my LinkedIn account. If you'd like to link in with me, send me a message and mention Code Rage. Also, I invite you to follow me on Twitter. My Twitter handle is @CarrieJensen. Finally, you'll see URLs for my two latest books, Delphi In-Depth FireDAC and Delphi In-Depth Client Datasets. At these URLs, you'll find links to buy these books in hard copy and in PDF format. Once again, thank you for joining me, and have a great day.
using Delphi as a no-code development IDE. In this session, I'll show you how to code simple programs, database programs, without coding anything. We'll use Delphi, and I'll show how to draw interfaces and use databases, use web access, and code a CRUD application. Create, read, update, and delete, and of course list datas. I'm Patrick Pomartin, Embarcadero MVP, freelance Delphi and web developer since 2000, Delphi user since the beginning and before with Borland and Turbo Pascal, coder since a little more in a lot of languages, but forever a Delphi fan. You can follow me on GitHub, itch.io for games, Twitch if you want to see live coding sessions, game coding and other programs. My blog, developerpascal.fr, and LinkedIn. What's Delphi and how it works? Delphi is an IDE. It uses the language to code Object Pascal. It gives us a lot of libraries and coding interfaces. And finally, Delphi has visual and non-visual components for designing user interfaces. It's what we use to create programs without coding. Since Delphi 1, we can create programs with visual components and don't code anything for databases applications. Current programs can run on Windows, Mac, Linux, iOS, and Android. Let me show you how to do this with Delphi 11 Alexandria, the last release. How it works. In Delphi, a program is a project. You can create Windows-only programs with VCL projects, and you can create multi-platform programs with FireMonkey projects. The same program can work on Windows, Mac, iOS, Linux, and Android. How to draw user interface. Create a new project, VCL or multi-platform FireMonkey. Delphi will add a form, the canvas where you'll draw the user interface. Simply drag and drop your components from the components list and it works. I create a Windows VCL project. I have a form. It's the window of the application. And I have a lot of components here. And those components can draw the interface. We simply drag and drop them. And we have actions. I save the project. and I run it. Of course, if you want to do something with buttons and other components in the interface, you need some code. But a lot of them don't need it. Using databases. In the past, we had the Borland database engine, BDE. It's deprecated and was replaced by DB Express, DBGo, and now FireDAC. FireDAC can manage databases directly from the IDE and of course in the projects. Add a connection to your database, add queries or tables, and link them to visual components for displaying or editing your data. I create a new FireMonkey application for Windows, Mac, Linux, iOS, and Android. I put some components, string grid, a navigator, we can use direct access to some properties. And now I add the database. I use a sample database here, SQLite, but I can use TFD connection directly, TFD table and queries if I need. But for sample, it's easier to use this one. So, employees, I have a connection, I have a query with SQL. I open the connection, I open the query, and I link the query to the string grid with live bindings. I do the same with the navigator. The buttons on the bottom of this form. And for sample, I add the edit here. And some label. Here. I link the label to the query and the same for edit. Label will be the employee ID. Edit its last name. I select all components and change them merges. no code. I can edit the data. Okay. So, yes, FireDAC and VCL is more easier. New project for Windows only. TDB components are directly linked to databases. DB Grid, TDB Navigator, TDB Edit, and the same table, sample database. I add a T data source between the table and the components, the visual components. Same data source for the three components. For the grid, I choose the table. The data source is the table, so I have nothing to specify. For the edit, I need to specify the field here. Country, for example. I open the connection and the table. And as I have the same program, it's functioning, I can change data directly in it. Where is the country? Here. How do you add screens in a program? By coding, you can use any forms you want, any number of forms you want in a program. With no code, you can't. So you use only one form, the first one, and tab controls to show, to simulate other screens. Here you have tab control, you add items. Items are your screens. I take it as client for the element. The first tab will be tab item 1, and I hide the table. Where it is? Here. Tab position, done. No tab. So I put something in each one. Before that, Here I need this. So in first I put a label and a button. In the second one, label and 2 buttons. On the third, label, 3 buttons. Here it is. So, label, okay, button here. Label and button are on top with margin. In this one, label is okay, button 2 and 3 are here. Top alignment and margins. I use alignment because I can change the size of window if I want. Monkey project can run on smartphones, so you don't know the size of users' screens, so you have to adapt it automatically. And the last one, button, label, same properties. Here it is. So, first one, up, second one, third, and fourth. In the first, I want to go to the second tab when I click on the button. I just have to add an action list. The button is linked to the action list with a standard action, change tab, or next previous if I want. I use change. This one, go to tab item 2. My page, yeah. I have a tab property here. The button is linked to the action, and the action go to the item 2. Same on the others. Up. Ouais, I changed it after that. Check. This one. And this one, page 3. This one to first screen. This to the second. And this one to the fourth. This one is named first page. Page 1. Page 2. Page name. Page 3. And fourth. And this button is exit. I save the project. And I hide the tab control. First one to start, it's okay. Here it is, okay. You can see the page slides. It's automatic, you can reverse it if you want. If you know the size, the position of the one, you can change it. So, next one. For Web API, you have REST components and web browsers. It's very simple to use them too. I show a simple sample here. A new project for VCL, Windows. I use an API up here. I can get all books published during the last year with this URL. And now I add components. Oh, no, I don't add components. I use the tool for this, debugger REST debugger. The URL is this one. I'll try it. Yes, good for this. And I have an item. I can copy components, paste them. It creates a database in-memory table. And if I execute response request here, if I execute the request, here, I have the answer in the table. I can use a string grid or other component, link it with the memory table. I'm in VCL. I can use DB components and data source. Memory table to the data source to the grid. Of course, we can do more if you want. Yes. Request is here. Ah, yes, we can't execute the request automatically for now. I've forgotten this. Sorry. Hop. One line code. Sorry, it's not no code, but low code. News. Qu'est-ce que c'est que ça? Little change. So, the read. It's here, modification, alignment, here, okay, and execute. If you want to know more about REST components, you can see David Cornelius' session in the DelphiCon 2021. Just one more thing. You have a web browser in Delphi. We can show local HTML pages or web pages. What's the problem? Oh yes. New one. We have Edge or Internet Explorer on Windows. And sometimes we need a little DLL for Edge. I didn't install it on this computer. So I have my page. Simple. Now we can code a CRUD application with only drag and drop. You have samples here on GitHub. I show you a previous project for a French webinar about no-code Delphi coding or coding in Delphi with no code. Yep. It's a Ssl project. I use tab items in page control. I have clients, orders, and lines. If I change client, I have its orders, and if I choose a line, I have the good items of the line order. And you see nothing in the code. Let's create the same thing with FireMonkey. I create a new FMX project, empty, page control, tab control, sorry, page control in VCL, tab control in FireMonkey. I do it as client. I need some items. I need an action list and a table or more. So I need 2, 3, or 4 tables. So I use another file, a data module. Where I put the tables and the database connection. So client customers here, and orders and detail. And products. In FireMonkey, we don't need data source to link data sets, table or queries to visual components. But we need data sources if we want to have a master detail linked between 2 tables. So here I need the unit 2 file use unit or alt F11, function 11, interface, good. I put a grid here, string grid, navigator, and button. Yep. Yep. The grid take all the form page client. I want the button in the right of DB navigator, by navigator, so I put it on the bottom. I put the button at right in the navigator and add margins. So the button is 80 pixel width. Here I change the margin, right, 80. The button, right here. So the button will go to tab item 2. This is customers. Name, page, customers. This one, orders, name, page, orders, order details, the first none. Up. So page customer here. I have to link this to the customer table. Late binding, string grid to customer table. The same for the navigator. I want only first, next, first, previous, next, and last buttons. So I the others. Insert, delete, knack, refresh. Okay, and I activate read only on the table. It's not a table, it's a query. So there is no read only on it. Il était où? What option? No read only. I have to change it. Check read only, yes. Check required. Read only. Here. So I save the project as FM example. So, activating the connection, connected, customer table activated, open, I have the data. For the order, I do the same, a grid, a navigator, and 2 buttons. Here. Navigator on the page, button 2 and 3 in the navigator. Button 2 left and margin 0. Sorry, not 0. Left minus 80. Button 3 right here and alignment right. Okay. Bind navigator buttons. Tac tac. This one refresh and the movements, and it is on the bottom of the page. And we have margins 80 on the left, 80 on the right. The string grid is client. Okay. Now linked to the orders, bind 1 is okay, string 1 bind machin, okay. The second one, order table. Order table with the string grid 2 and order table with bind navigator 2. I activate the order table. Okay. And I have the orders. But I have to filter with the customer ID. So here I add a T data source. I link it to the customer table. And I use it as master dataset, so data source, in the orders. The field, the primary field is what? Customer ID, I suppose. And I use an index by customer ID here and order ID or date. I put it read-only too. And it's active. And I have the filtered lines. Same for the third. The order details, string grid, bind navigator, and 2 buttons on the left of the bind navigator. Bind navigator on the bottom. Here, string as client. Bind navigator margin left 160 and buttons, visible buttons here. Button 4 left here and button 5 strange Okay. They are on the left. I suppose it's okay because the first one is at outside the navigator. So I have to link this to the third table. Here it is. So order details with string read 3 and by navigator 3. I activate the table and add so customer ds customer order table order table and data source orders. Order detail here. Read only two with master field and master source. Order ID here, field name, order ID, and product ID. I do the same with the product table. Here it is, I activate the query and product table, master, where are you? Here, detail, field, product ID, index field name, product ID. And read only for this sample. Okay. I save all. Here, I have the detail and I add the product. Edit field, yes. So I have the product here. With an edit here. Yes. The label is at bottom. The edit is right. No. Label. Product. And the edit there. So if I change the size, it's okay. I put margin top and bottom, 5. Okay, left and right. 2. So I have to link the edit to the product name. Where is the product table? Here. And the edit is here. Product name, edit text. The edit here is read only. And it's over. I have to change the buttons. So in the first screen, this button go to orders. So I use an action. Change tab. For the other button here, it's customer, so I have a new action for this. Change tab, and this one for detail. In the detail, first one is customer, second orders, so customer, I need a new. No, nothing, I have already have it. So, my actions, here, here. Go, customers. Just rename the page for their details to have the same names. Customers, it's okay. Page customers. Here, orders. And the third one for the details. Just link them to the buttons. This one on customers, it's orders. Here. And I change the text. Here. In orders, it's a button to client, customer. And I change the text of the button. Details. And this one, first is the customer and the orders. Here it is. I save the project. I choose the first tab item in the control. Active tab. Page customer. Tab position, none. And go. No code. And something nice. Using Delphi for creating simple database apps is easy, and you don't need to know how to code. Use it for your personal databases, for viewing or editing them, for sample projects or prototypes. You also can use Delphi without coding during a startup weekend, hackathons, and other events. If you need a program or mobile apps to explain a concept or win a challenge. Just one more about prototypes. You can use it with no database in your project. Create a multi-platforms project, Monkey, and use the prototype component. You can edit fields and create some of them. Contact name. It change. I need some picture. Contact bitmap. Okay. A simple list. And images. the list as client and the image at right. Or none. Top right. Left top, no. Right, yes. And size, a little. Up. Okay. I put it there. And here. I link the prototype to the list view with live binding. So I have a contact name in the text. Synchronize the list. Yes. And use the bitmap in the image. It was VCL. And this one was FMX. We can generate randomly data and use them as we want with it. You also can use the TFD mem table, the in-memory table from FireDAC. Because you can edit it directly in Delphi. I use a string grid. Sorry, TDB grid. A data source between the memory and the grid. Client, up. I edit the mem table, so I use new fields. ID as integer. Label as string. We can edit datas directly from the ID. You can use persistence in the memory table if you want. Just specify a file here. It loads it on startup and save it when closing the program. So you can edit data directly from the program without having a database. And with no code, of course. Yep. I finished. I hope you'll see little more how to code with no code in Delphi, just with using components. I'm not available for the Q&A during the DelphiCon. You can talk to me on LinkedIn if you have any question. Or on my blog, developerpascal.fr/contact. You can talk to me directly on Twitch during a live session for coding, game, or others, of course. And it's better if you write in French or English because I'm not very fluent in other languages. So, thanks for watching. And enjoy the DelphiCon.
So this is just a quick look at creating a database application with C++ Builder. I'm going to go use C++ and do multi-device. This should work mostly the same with VCL, but the difference is because I did multi-device, I have more platforms over here. So VCL, you just have Win64 and Win32. Also over here, we have the Data Explorer tab. This supports both FireDAC and DB-Express. FireDAC is the way to go, although if you want to use DB-Express, it's there too. And we're going to use Interbase. Right now, we ship with the employee database, just a sample database. So if you've installed FireDAC and have it set up, then you will have the employee database. And I can connect to that and see the tables. And we're just going to use the customer table here. If you want to add others, you can add new connection. It's going to ask you for a name, and then it'll bring up a dialog like this one where you can specify the driver and the database username, password, stuff like that. So I have the components down here in the form. This is the connection to the database. This is the connection to the table. I can go to the query editor. By default, it just selects star from customers, and I can execute this and see down here. Actually, put this down in the corner. There we go. See all the data and see the structure of the database, the data in the table, and say, yep, that's what I want. You can optionally, this isn't required, come here to go to Fields Editor and add fields. And this will create variables for each individual field, but this isn't necessary. And now to display the data, I'm going to use a grid. I'm just going to use a regular grid, T-grid. Let's I want to drag the whole thing. Or not drag it, I want to resize it. And then we'll go to bind visually. And there actually is an option where you can run the wizard here, the bindings wizard, and create a grid automatically. But I don't know. I don't do that. I probably should learn to do that. I like doing stuff manually, believe it or not. Okay, so I just connect the grid, the star on the grid, to the customer table. But when I did that, it actually created this binding source DB and binding list. And you'll notice it changed this to say bind source DB down here at the bottom. Now and you'll see that the grid now has columns in it. Now I can go to this and say active true and see the data at design time. I can even hide those components if I want to. Before I do that, I'm going to go to the bind source DB and say add navigator. And this puts a navigator bar that just makes it easy for this quick and dirty CRUD application to navigate through the data. And I do need to write one line of code. In production, you're going to write a lot more than one line of code, but you know, this is just quick and simple. Customer table open. Oops, star in there. I was also going to show you, you can come in here to the columns editor and add columns. Again, this is optional, but this gives you the ability to come in here and change the header from cust number to cust number sign, because we're fancy. Oh, let me hide the, there we go. So now it says cust number. Okay. And at that point, my project's all ready to go. So I'll just run it. Give it a second here to compile. And there is my application. And I can come in here. And if you watch the bar here, when I click in here to edit the cell, as soon as I start editing it, so we'll change it to big, we'll see that we now have the commit button here. And I can click that and commit it. Or if I say, as soon as I go to the next row, it commits it automatically. You can also use this for add, refresh, navigating to the top and bottom, stuff like that. Anyway, there you go. Quick and easy, simple, creating a CRUD application with C++ Builder, connecting to Interbase using FireDAC. Hello, good morning, good afternoon, or good evening, whatever time zone you're joining us from. This is Jim McKeith. I'll turn the webcam on here for just a minute just to say hi to everybody. Welcome to Local Cloud Data Management with Interbase and Amazon Web Services. I did put the link, I'll put the link for the blog post in the chat, and I will also have the slides available in the handout section. So if you're on the live webinar, you can grab those from there. And the link with the replay and everything will be available is up in the chat, but the replay obviously is not up yet because we're live right now. Okay. So first question, what is local cloud? Part of this might be a little basic, but I think it's a good idea to make sure we're all kind of on the same page when we're talking. First thing, and this, I think this is a useful thing to talk about when we're talking about different types of cloud, is the idea that this is one of the things when cloud first came out, people were like, there's no cloud, it's just somebody else's computer. And that's the really important thing, is really when you're talking about cloud, is you're talking about you know, it's somebody else's computer. It's what it is. It's a server somebody else manages for you. Generally, we refer to the cloud. But in the case of local cloud, right, that's maybe someone's managing it for you, or maybe you're managing it. But anyway, so it's a server someone else is managing it for you. Why would you use the cloud? Well, why do you take your car to the mechanic? You know, at least, I don't know, I don't repair my own car. Sometimes I try to, but I realize pretty quickly that's not a good idea. And the reason we take our car to the mechanic is because the mechanic is a specialist, and you know, we can spend our time at other places. And that's the same reason we use the cloud, is that we're effectively outsourcing the server platform management to the specialist. So in the case of a mechanic, we're outsourcing the car maintenance to a specialist. And this gives us, you know, the mechanic is a lot more efficient at it because they do it all the time. Or the cloud, you know, their server, the people managing the servers there are much more efficient at it because that is what they do. They do that all the time. So it gives us economies of scale. It reduces our workload and effort so that we can focus on other things while leveraging the expertise of a specialist. So the cloud makes large scale computing power accessible to everyone or anyone, which is especially true with Amazon AWS, is it's really, really easy for anybody just to get going with AWS. Oftentimes too easy. Then it also enables you to cut costs, and you can focus on your core business instead of being impeded by IT obstacles. I've worked with more than one person, I was going to say, but way more than that. Quite a few people that were maybe hesitant to start using the cloud, and then once they did, they're like, "Oh, I should have done this years ago." There is a lot of there's a lot of good resources out there for learning more about using the cloud, but generally, you know, if you are hesitant to using the cloud, you know, look for small things where you can start moving things to the cloud and discover some of the benefits of it, because it does save you quite a bit of headache sometimes for doing things. But generally speaking, the cloud, you get sustainability, elasticity, and security. You have more of that and reduced cost, effort, and risk. But some of the drawbacks of the cloud is reduced control. So if you're like, hey, I want to have maximum control over what I'm doing, then you're giving some of that up because it's being managed elsewhere. There can sometimes be privacy issues. So it's interesting when Microsoft acquired GitHub, for example. So GitHub being effectively a cloud-hosted source control, there were a number of companies that withdrew from GitHub because they were like, whoa, hold on. We feel like we compete with Microsoft, and we're not sure if we're comfortable with Microsoft having access to our private repository. So while I think generally speaking, it's interesting, I have a few patents, and I've done some like inventing and patent boot camps and stuff like that for people. And you always have somebody in there that has some idea for a invention, and that they are so in love with their idea, the thought of anybody having access to it. So they're like, what if I send my patent disclosure into the patent office and the patent clerk steals my patent and goes out and makes it? And it's like, generally speaking, that's not going to happen, but I do understand, especially in the situation where you are, you could be potentially having your data hosted by a competitor. So this is having some audio problems. That's interesting. Here, I can change this here. Let's see if this is better. Is that better for the audio? Hopefully. All right, I'll keep an eye on the feedback here in case someone says something. Security concerns, and so this is kind of an interesting one, because generally speaking, a cloud provider is going to have more skilled people involved in security, focused on security of the platform. So they're going to generally be better focused on be able to provide better security. But the flip side is that if somebody is trying to create an exploit, they're trying to compromise somebody's security, if you're a small-time company, you may not be on somebody's radar as being somebody they want to try and compromise. Okay, sounds like the audio is better. Great, thank you, everybody. But a big cloud provider, on the other hand, is a very juicy target. So while they have better security defenses, they are a bigger target and more likely have more people trying to compromise them. So if there is a compromise, it impacts everybody on the platform. So it's kind of a weird dichotomy there. In that it is better security, but also greater risk. And I don't know. I haven't seen actual numbers as far as like figuring out the overall impact, but it is something to consider for sure, is that you are giving some of that control up, essentially. And then the last one is jurisdiction complications. And this one comes down to issues where if your company is based in one country, but you're using a cloud provider from a different country, then there can be concerns about data being hosted in other countries and different laws and how different laws apply and stuff like that. So those are some of the things, some of the concerns people have around the cloud. And I'm not going to say that any of these are invalid or reasons not to use the cloud either way, but there are definitely things that you should think about and consider in picking a cloud solution. So that's where local cloud or private cloud comes in. Essentially it's the benefits of the cloud but it's on premise and you have fully under your control. The idea being that you want to take something, some of the main benefits of the cloud being that it's kind of like you don't have to think about maintaining it, right? It just works, which everything that just works never really just works. But anyway, the idea that it's not something that requires a lot of maintenance, right? It's something that can provide you, the users within your organization, the services they need for storing data without the headaches of trying to think about managing the storage of the data. And then you also have what's called hybrid cloud, and hybrid cloud is where you kind of combine the two together. You combine public cloud and private cloud or local cloud together. So you have local data and cloud data, and you get the benefits of both. So for example, a simple to comprehend solution for this, for example, is that you could have local data that's stored on premise, that's maybe on device or on your local network that multiple people can access it locally, but then you have data that can be bounced off the cloud or hosted in the cloud to give people access to it outside. They don't have access to the local network. So instead of having people VPN into your local network to access data, they can instead access it through the cloud. And so this way you're able to replicate the data in multiple locations to give people access to it as they need it. Or It could be that you're using the cloud to back up your local data so that your data is backed up off-site, for example. It's another description of local hybrid cloud. There's a lot of big cloud providers that sell hybrid cloud as a sometimes they'll sell hybrid cloud as the local cloud, or the private cloud is something they sell you as well. So it's like, hey, we'll give you the service that's on site and the service that's in the cloud and manage it all for you. There's a comment here. It says, related to reduced control is reduced ability to verify and audit, particularly for SMEs who have limited market power to get contractual rights they might want or need. How do you know your cloud provider has really deleted something when you press delete? I've had this conversation actually before with other people around other things related to this. It is generally speaking, you know, you have SLAs with the cloud provider. You know, they specify this is what's going on and how it's working. So, for example, if there's different types of cloud services you can get, and I have some actually. Yeah, so I'll bring this slide up because it lists some of the different types of cloud services you can get. But if you are using a storage platform, let's say Amazon S3, which is their simple storage solution, that one is you're putting individual pieces of data in the cloud. It gives you this idea of buckets, and you're putting something in a bucket. And then later you can say, I want to delete what's in that bucket. In regard to James's question, how do you know that it's really deleted and it's not in a backup someplace? Yeah, you're not going to really get the ability, I don't think, to go actually physically audit their storage to see that it was actually deleted, but it should be deleted. But then again, the flip side of this is that anytime your data is transmitted across the internet, it's actually stored on all these individual servers as it's transmitted. Now, but the reality is, typically the servers are immediately deleting it, right? They're just storing it briefly in memory to retransmit the packet. Now, in theory, one of those servers could keep a copy of that data, keep a copy of those packets. And so the reality is that when you really get down to the nitty gritty, there's a lot of things we have to take on faith, as it were, that is working within the way the systems are defined. So, you know, even if you are storing it on site, right, you delete something. Well, does delete mean that you've erased it from the disk? Because if you just delete a file or just delete a record, sometimes that record is just marked as deleted, but still exists in memory or on disk someplace, right, until it's overwritten. And so it's that same sort of thing, is that you can really, you know, when you're a technical person, really get into the nitty gritty, the details, the minutia of what does delete actually mean. Now, so I think generally speaking, it's not as big of a deal, but that, you know, certainly is something that can be a concern and something that, you know, you really kind of need to stay on top of to make sure that things are happening the way they're expected to. So this slide, though, kind of shows some of the different models of local cloud, hybrid cloud, traditional cloud. So on-premise is kind of the traditional data storage solution where you manage everything. And then SAS is the traditional cloud, as if you will, where it's software as a service, where everything just, you don't manage any of it, someone else manages it for you. But then there's other times where you mix it up, and right, sometimes you have the idea of platform as a service, where they essentially it's like you're getting a virtual machine in the cloud, right? Where the cloud has the platform and you run all the data, you manage all the data, you manage all the applications on that platform. Infrastructure as a service is actually lower level. So actually, a better way to analogy would be that infrastructure as a service is essentially where you're getting a virtual machine in the clouds, whereas platform as a service is more like a container in the clouds. So I'll talk a little bit about what the difference between a container and the infrastructure would be. But in both those situations, you're managing the data. Now, especially with platform as a service, you might be getting backups, and that's not listed here, but sometimes some platform as a service solutions, they're like, here is your instance you're working in, and you can say, I want this backed up regularly, which backups are important. You should be having backups. There's the saying that there are those that have backups and there are those that will wish they had backups at some point, because at some point you will need them, and you don't know that they're working until you discover they're not. So if you're even if you're using a platform as a service, or possibly even infrastructure as a service, you could have a situation where you want to make sure you're paying attention to your backup, how long your backups are being kept and stuff like that, because sometimes you do need to be aware of when things are actually deleted. So that's where Amazon Web Services come in. I think I alluded to this earlier as well, but it's probably the biggest. I've heard people say it's the biggest, but I hate to say, I don't like to use absolutes like that, but it probably is the biggest, most comprehensive cloud platform. I think everybody else is really playing catch up to reach Amazon's level. Not to say that there aren't advantages to using some other cloud providers by any means. But one of the things about it is it's on demand, this idea that it's completely elastic, in that you could say, hey, I really need a lot of cloud services this week, and you can increase what the services are available, but then as soon as you're done, you can turn that services back off. You can have some services that turn on just when they're needed, for example, as well. So I have a friend that works in kind of a cloud management. Ian says no one's had a problem with having too many backups. Yeah, you always want to have, if you can have multiple backups at different levels, always do it. But again, when it comes to auditing to make sure something is deleted that you expect to be deleted, then you need to be aware of that as well. But again, that's getting more into the technical minutia of maybe the data still exists in some sort of ephemeral state that is electrons traveling through the cosmos. Anyway, I have a friend that works in cloud management, and he says one of the problems people have when they move to the cloud is if they have a server that is used only occasionally, right, and they move to the cloud and they have it as an always-on service, then they're paying way more money for it than they should. But if instead they can make that service an on-demand service, so the server only spins up when needed, that's when you're really going to come into big savings. So elasticity is kind of that idea. But so it's build metered pay-as-you-go basis. You can set limits where, like, hey, expand the usage as much as needed, but then stop before, if it reaches this amount, stop, or stuff like that. So that you're not gonna, you can properly manage it in order to prevent unexpected surprises, but you do need to put that effort in. It's not just as don't go into it blindly. One thing though is also AWS and most other cloud providers are on server farms throughout the world. Now, that means if, for example, the European Union has some different laws around data protection than the rest of the world, so you can use a server in the European Union. Now, you still can have some jurisdictional concerns because technically that server is owned by a US-based company, so does that change things? And it can get weird. Generally speaking, it's not as big of a deal for most people, but especially if you're in a situation where you have government data, right? You need to be aware of those requirements by the government. So I mentioned Amazon S3 simple storage solution earlier, but we're going to talk about Amazon Elastic Amazon Elastic Compute Cloud, or EC2. What it is it gives you the ability, this is that platform as a service, in that you can have a platform that you just turn it on and off. That exists when you need it, and you can have multiple platforms that come up. They have high availability, and you can choose different types of platforms you want to have. This is a great kind of getting started with cloud solution, because you can essentially take what you're currently hosting on a local computer and move it to a computer in the cloud. There's been a few times that I've use this for different things. I'm not really involved in the infrastructure of Embarcadero and Idera, but there's been projects I've been working on that I've moved from a local computer to a cloud-based solution, for example, to get better bandwidth, because once you're in the cloud, you're reading and writing over that Amazon's internet connected backbone, and that can make a huge difference. So this can be used in like an ad hoc basis to be very effective for a number of things. So once you have an EC2 instance, then you can host Docker containers on that EC2 instance. So I mentioned Docker earlier, but Docker it's different than a virtual machine in that a virtual machine includes the guest OS, whereas a Docker image does not. So essentially, you can think of a Docker image as all the libraries and programs that you install on top of an operating system, but that is separate, and that you can have the container that you build locally, for example, or on a local server, and move it to a cloud server and know that it's going to run the same. So it doesn't care what platform it's on, right? It doesn't care if it's on a local computer or a cloud computer, it's going to behave the same. Additionally, in that Docker containers, if you can have multiple instances. So if you're like, I have this server, and generally it's able to run on one instance, but let's say, for example, I know I'm getting a lot of demand coming, or I want to be able to respond to demand that happens dynamically, you can replicate that Docker container, and each instance of that operates exactly the same as the first instance. And that's the advantage of containers. So Thomas is saying GDPR rules in Europe generally make it mandatory to know where data resides and who can access it. Yeah, exactly. Gabriel's asking when will DAAS be available? I'm guessing, is that data as a service? I'm not sure what that, either I don't recognize it. So if you can elaborate on your question, Gabriel, I will try to answer that. But yeah, these big cloud providers are very strict about data access because of those requirements. So you know, especially if you're using a Docker container, is you can actually control it, add additional layers of control in there to prevent access to the data within the container, right? So even though that container may exist on a cloud server, that data can be encrypted. Oh, Jay's saying desktop as a service. Yeah, desktop as a service is a thing. I use that a lot as well. DAAS, desktop as a service. Amazon has some solutions. There's a number of ones as well. Vultr, I think, is one that I've used recently. Yeah, so that's an advantage of using a DAA, or I'm sorry, that's an advantage of using a Docker image or a virtual machine, is that you can encrypt what's in there. Also with Interbase, which we'll talk about here in a second as well. Actually, Interbase is the next slide. So Interbase is, of course, Embarcadero's database server, or yeah, database engine, and the interesting about Interbase is it's kind of a combination of the three common types of databases out there. You have your traditional server databases like Oracle, SQL Server, etc., that are your big databases that sit centrally, and all these clients connect to that database, and the database controls the data that's shared between all of them. You have your desktop databases, which are great for you have like single user instances where they have a database that's installed on a desktop, and that you maybe have multiple applications, or you're at a single application that talks to that database, but that database then manages all of that data for you so that your application doesn't have to worry about that. But then you have embedded databases, which are focused on typically like mobile, especially, where the database engine is embedded into the application, And it's similar to desktop databases, it's just maybe a little more lightweight in that it's specifically designed for embedded and also supports mobile. So Interbase is like the best of all three of those because it supports all of that, in that it can it can work in any of those scenarios. It has strong encryption and security, which is really important, especially when considering cloud options, in that you set up that strong encryption and security, and then you can know that even if that data was replicated on that cloud, that without your credentials, without your keys, no one can access that data. So this gives you absolute assurance that your data is secured, even if you're not sure that the data is being, or how long the backups are living, for example. There actually, I could go on a while about Interbase's security. It has column level encryption, which is really cool, in that you can have different users that can access certain columns or not, which is a feature in the past when I wasn't using Interbase, I wished that I had. Just answering some of the questions here. I'll come back to those. One of the things though about Interbase, kind of its general theme, is this embed, deploy, relax idea, in that it doesn't require the database administration to the same degree as other databases. It's self-tuning. And most databases, you know, I used to work for a company that did Oracle consulting, and the joke was that, you know, that the cost of the Oracle database, it might as well be free because it's so expensive to install and maintain that, in that you have to hire all these consultants to come out and take care of it for you. That's where the real cost is. And that's kind of the opposite for Interbase. Interbase is designed around the idea that it doesn't need to be administrated. So it's used in lots of situations, mission critical contexts and such, both embedded, desktop, and server databases. Again, administration free, transparent data encryption, journaling and point of time data recovery, disaster recovery. A lot of things we're not going to talk about today, but just good to know about things about Interbase. But I do want to talk about Interbase feature called change views. And so first, to talk about change views, we need to talk about traditional data briefcase. So a traditional data briefcase is this idea that you can have a copy of the data that you then offline copy. And this goes, I think one of the questions is about this. So how to prevent data loss if you have intermittent connectivity. And so you can have your traditional briefcase where you have a local copy of the data and you make changes to the data, and then when you reconnect, you send all the data back. And so in this situation here, here's your central database, and each of these represents a connection where you're sharing data back. So here we have the 4 rows in the database, and here we've changed 1 row, but we still have to replicate all those rows back. And here we've added a row, and so we have, again, replicating all of this. And so the number of rows, and these are small numbers, but this scales as well. So the idea is you want to see the pattern here, in that in this situation here, we've changed 4 rows, but we still have to manage this because it's a traditional briefcase. Now with change views, you only have to transmit and deal with the changes themselves. So in this case, Interbase keeps track of the rest of it for you. You don't have to be think about it and be concerned about it. And there are other ways. I've worked at places before where we've tried to replicate solutions like this manually, but the idea with Interbase is it's built in. It just knows how to do this automatically, where it only needs to send between the local, right? This could be your mobile device or local computer, your local cloud, and the central, the cloud computer, the changes. So what's changed? And so in this case, we went from 23 packets to 9 packets. Now, that's not a huge change, but when you scale that, that is a very big change in that you only, if you had a huge database, this gives you the ability to only have to be concerned about and only deal with what has changed. There's a couple questions here. Let's see. So some comments, more comments about just this idea of knowing that auditing and stuff like that and who can control it for sure. That gives you the advantage of using a approach like this, where you're using interbase is encrypted in the cloud, is that then you know for sure exactly who accesses your data, where it's being stored, and how it's being stored. And if they don't have your encryption keys, then they can't get to the data. So even though the data may be on a cloud provider, or a great example is that if your data is maybe on a mobile device or a laptop or a removable media, if you have the strong encryption the Interbase provides, then even if that device is lost, physical access to the device is lost to a completely untrustworthy third party, even not one that you're expected to trust on faith, you know that the data is protected and can't be accessed. So the question here, how much work is involved in setting up change views process? Glad you asked, Michael. So here's how you create a change view, and the link to DocWiki, which the slides are in the handout section, and they're also in the blog post. Did I put the blog post in the chat? I didn't. Let me put that in there right now. There you go. So you can go out and get the blog post there with the slides. So here's the create a subscription, and the links down at the bottom or in DocWiki that goes into more details on this. But you create a subscription, you give the subscription a name. So in this case, we're naming it Sub CEO Multi-Device because it's a subscription for the CEO that works across all their devices. So what we do is just say on employees for when rows are insert, update, or delete, customers insert, update, deletes, sales rows if they're updated, and department locations for updates as well. And so this is how you define what you want to subscribe to. You can grant and revoke subscription to different things. So this gives that user level control of who can subscribe to things. And then to use a subscription, you activate the subscription, and then once it's activated, you can select, or once it's activated, then when you do a select, it gives you it lets you only deal with that updated set. And so it kind of automatically scopes that for you to what has changed. And so you don't have to worry about things that haven't changed on either side. So there's a comment here about conflict management between updates from different clients. You can define rules for that. There's a few different ways you can define it. You have the flexibility to deal with that, but it's kind of beyond the scope of what I was planning to talk about today, but there is some resources. Actually, I'll try and go and add some more resources to the blog post as well that go into more details about that to explain that. If you do want to set up Interbase on Docker, we do offer a official Docker container image, which is on Docker Hub. And there's the path to it there. We actually have for 3 different ones. This is the full one. The other 2 are kind of scaled down versions. It also includes PA server and RAD server. There are other unofficial Interbase container images out there, but I would probably use the official one or make your own, and that we have the Docker script here, Docker file, so that you can go out and modify that and make your own Docker container. And then I was going to show a demonstration of how you would set up your Docker image running Interbase. And this actually goes into RAD server specifically, but which I'm not getting into Rad Server. I'm trying to keep things simple today, but you can certainly use that as well as an option.
We're going to demonstrate the PA server RAD server combined Docker image right now. So we're using the Windows terminal, the new Windows terminal from Microsoft, and we're going to SSH into our machine here using the root user. And then we're going to run sudo apt update, which is going to update our machine. And then we're going to run sudo apt install Docker, and that's going to install the Docker files that we need to run our Docker images and containers. So you can see the RAD Studio IDE in the background, and we're going to deploy from that a little bit later in the video. So you can see that this is our host machine where we have our Docker images running, and you can't connect to the machine right now because there's nothing on port 80 from a web browser. So now we're going to run the Docker pull command for the RAD Studio PA RAD server-IB image and pull that from Docker Hub. And I've already done it before, so here it is. So now we're going to run this image. And so this image, the PA RAD server-IB image, is an image that contains both PA server, RAD server, and interbase. And we're going to run interbase only mode. So we're going to run this Docker image because we need something for the regular Docker image, which doesn't contain interbase to connect to. So we're going to do docker run -d, which is in the background. And we're going to do config equals interbase, and we're going to run on port 3050, and that's the interbase port. And then we're going to mount the two directories, the interbase directory and the EMS directory, as persistent volumes. So we're going to run this command, and so now we have our interbase only Docker container image running in the background, and now we're going to pull the RAD Studio PA RAD server image, the one I talked about, the PA RAD server combined Docker image. And now we're going to run this image, and we're going to run this image in the foreground using the -it command, and then we're going to mount its persistent volumes as well. So the name there is EMS2, that's the name of the volume, and then there's the directory from inside the Docker container that we're going to mirror to the volume. We're also going to supply these arguments here. We're going to do DB port of 3050, which matches the 3050 we ran in our previous PA RAD server IB image. And then we're going to do the host IP address of this host machine here where the Docker image is running. And we're also going to open up port 80. We're going to open up port 64211. And we're also going to open up port 8082. And we're running the Docker image RAD Studio PA-RAD server. And so we ran an interactive mode, and so now you can see we have PA server running, and I turned it verbose mode on, and then you can see here, I'm going to demonstrate, you can see that RAD server is actually running on the machine now, and we ran the version command. And then we're also going to show you that the test endpoint, and you can see that the test endpoint does not currently exist in the RAD server image that we're running. So we're gonna fix that. We're gonna go over here to the RAD Studio IDE, and we're going to change this option here for the package output directory to /, and that's going to compile the package file into the same directory as our project. So we've compiled the project now, and our package file is there. We're going to switch over here to RAD Studio Docker Deploy project, and then we're going to go here to resources and add that file. We're going to add that file here to our project. So we're going to add this as a resource, and then we're going to name the resource identifier module, and so that tells it we're going to use that in the code to deploy that module file. So we're going to clean the project, and then we're going to make sure everything is good after adding our package file. And now we're going to deploy this project directly to the PA server that we started up in the Docker image. And so this version of RAD server is connecting to the remote Docker image that we started at the very first using the PA RAD server IB image. So it's uploading this image to the cloud server right now where our Docker images are running. And so after it uploads this, it modifies the EMS server INI file, and it restarts Apache to load the module in real time without restarting the Docker image. So you can see here, you can see the command line that it ran, you can see that it restarted Apache, and so now we're good to go. We're gonna bring up a web browser, and we're gonna test this endpoint. And so there you can see it returns test. And you can see here's the endpoint of test, and it returns test there in the code.
Okay. Come on. There we go. So with that, I'm going to go to questions. I did try and answer some of them as we went along, but if you have other additional questions or follow-up questions, go ahead and put them in there now. Here are useful links for you for more information. Again, really the first one you need is this first slide here, which is where you can find the slides, or hopefully that should be live now, and the replay and such will be available there as well. I'll put that in the chat again as well. Desktop as a service, GDPR, yes. So again, one of the benefits of using Interbase and its strong encryption is that you can absolutely know who has access to your data and what's going on with your data, even if you don't have physical absolute control of the hardware. So oh, Gabriel says DAAS is Delphi as a service. That would be fantastic. Actually, I've been working on something like that, trying to get something like that to happen, but nothing yet to report. That would be great though. But if you use desktop as a service, actually, I was talking to an MVP, and he says what he uses when he does consulting for somebody is he sets up a cloud instance that has Delphi installed on it and everything set up on it. And he uses that cloud instance just for that client. So that client, he buys a Delphi license for them and sets everything up. So it is all specific to that client. And then when he is done consulting for them, he just gives them the cloud credentials. So they have full access to it if they bring a different consultant in or whatever the case may be. So you can do that today. But it's a BYOD, bring your own Delphi to any of the desktop as a service providers. Do I have more detailed documentation? There is documentation if you go to Interbase change views right here. This has very detailed documentation on change views. You can check that out. Can I have a complete audit trail of transactions on Interbase? Is there any software to convert my real PC to a Docker image? Okay, so hold on a second here. Let's see. There is. So here's the change views documentation, and then there is audit functionality in. I just can't remember what it's called. I can't remember what it's called. There is audit functionality in Interbase, but you can also use, for example, triggers to create additional audit logs if you want to. That's kind of what a lot of people use triggers for, is to keep audit logs of who changed what and when. And that can be, the great thing about that is it can be customized. Software to convert my real PC to a Docker image. Let's see, actually, copy link address or detailed documentation. Here you go. So there is Windows Docker, but most Docker is Linux based. So there is a technology called Terraform, which I believe would do that for you. I'm not sure. You might try a site like Super User or one of those Q&A forums where you can go out and ask a question. Although the secret to asking good questions is to do a lot of research first to make sure you haven't missed something obvious. Although I frequently miss the obvious when I ask questions too. Let's see. The lack of verify audit capability, timing mismatch between question and answer. I wrote that you started talking about interbase. I was referring to more journal content like the kind you'd store in S3. Okay, got it. So yeah, so S3, they have, I mean, there's different services available with S3. You could, in theory, encrypt all your data you're storing in S3 as well. But yeah, there's different, depending on what you're doing, there's different threat models and stuff like that. Please make interbase to go for desktop. That would be cool. I would, so it's not my choice and my decision, Don, but you can, I think that I'll pass that suggestion along for sure. Jens is saying, even encryption won't hide your metadata. A number of security issues are related to the metadata, e.g. you don't need to know which pizza was ordered to know where it is delivered, as long as the delivery service provides GPS data, so you know when it'll be on your desktop. So there is a lot you can do to protect the metadata as well. Again, it really comes down to your threat model. And so you need to know what your threat model is. And so your threat model means what are the likely scenarios of, you know, who's trying to get your data, you know, how far are they willing to go, right? Are you worried about the a superpower, you know, or a government of a major company trying to access your data? Or are you worried about competitors trying to access your data, so big companies trying to access your data? Or are you worried about traditional, you know, people out there looking to make exploits and access your data? Or are you just worried about being vulnerable to ransomware and, you know, all the dangers that just lurk in being online? And so once you have that threat model, then you can figure out and then look at what kind of data you have and whether the data is, what data is more important than others. So you could, for example, Jens, use a setup a system where you are encrypting, well, actually, so you'd be encrypting the data coming to you. So they're trying to think what you would, if you had, so you could do quite a bit to prevent anybody from even knowing what data. I mean, if you really needed to, you could use Tor, the onion router system to protect what data is coming to you and where it's going for and stuff like that. Okay, and that would be a way that you could prevent the you know, any metadata at all from being leaked. But again, you really need to, you're never going to completely, absolutely protect everything from all instances, because technically, you know, the electrons that are in the storage, in the memory are, you know, there's bits of that seep out into the Ethereum. You know, there are so many crazy attack vectors that are technically feasibly possible, but that are not actually a concern, that you really, 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 really need to know what is your threat model. And once you have figured out your threat model, then you can find a solution that works for you. But if instead you're just like worried about every possible boogeyman, then yeah, even hosting it yourself in a bunker underground is not going to be enough. So Packer by HashiCorp is for packaging. Okay. Thank you, Jens, for that. So let's see, where was that question? I'll put it in the chat. It's all, so HashiCorp is the company that makes Terraform as well. Let's see. Here's an analogy for cloud service models. Infrastructure as a service is like leasing a car. PaaS, platform as a service, is renting a car, and software as a service is you taking a taxi or Uber. Okay, yeah, that's great. Where's the mobile server application demo for IB change views to test online offline capability? I think I don't have it offhand on, but I will look into that and see if I can get you or post it to include some details in the blog post. So check out the blog post and typed it wrong. And there's a link. I'll put the link to the blog post in there again, and I will see about posting some links there. If not, check out DocWiki, or if you look in the blogs, that's probably what I'll do, is go look in the blogs for the article that's been around that and send that out. Okay, with that, we're done. I think I've gotten through most of the questions, and hopefully this was informative and useful to everybody, and I look forward to seeing you online at future webinars. What's your timeline for next major interbase release? I don't know for sure and couldn't answer. So there's been some updates to interbase 2020. So yeah, there is. I can't really speak to roadmap and such, but there's been some updates, and as you point out, maybe time for a major update. So maybe we'll see, but I can speak to that. So anyway, thanks everybody, and we will talk to you later. Bye.
Hello there and welcome to the webinar today. I'm just going to get everything set up to go here. We've still got quite a few people just joining in. So I just wanted to do a quick check to make sure my audio is working, and then we'll be getting running in just a second. As we're going through today, then please feel free to use the GoToWebinar control panel to post in your questions, and I'll be answering those live through the session and also with some Q&A live at the end. Hello there and welcome onto this webinar. Today we are going to be looking at the top 5 reasons developers choose RAD Studio Enterprise Edition. My name is Stephen Ball and I am the Pre-Sales Director here at Embarcadero. If you're watching this session live, then please go ahead and use the GoToWebinar control panel to drop in your questions as we go through the session today. If you're watching this on demand, then please go ahead and email me. My email is stephen.ball@embarcadero.com if you have any questions, and I can always help get those answered. If you'd rather, then please get hold of me on Twitter. DelphiaBall is a great way to find me. So let's get straight into number 1, which is FireDAC. So FireDAC is our leading database connectivity components, which are part of the Professional Edition and also the Enterprise Edition. The difference between the Professional and the Enterprise Edition in some respects can be summed up pretty straightforward. Professional gives you great connectivity, but for local data only. So the data has to be located on the machine. There's not only licensing compliance for that, but there's also inbuilt checks within the product to make sure that the Professional Edition is only going to connect to local data. If you have the Enterprise Edition, then you can use the same database connectivity, but you can also then use that to connect to a remote machine across the network. So for example, if you've got a copy of Interbase running on your machine, you can connect to that with Professional and Enterprise. But if the copy of Interbase is running on a server elsewhere on the network, you'd need the Enterprise Edition to be able to access that remote data. The Enterprise Edition also brings in the ODBC driver. So the ODBC driver allows you to connect up to multiple different data sources, along with the standard ones that are included. So that includes Advantage Database, Firebird, IBM DB2, Infomix, Interbase, MariaDB, Access, Microsoft SQL Server, MongoDB is then added as well as the DB2 within the Enterprise Edition. There's MySQL, Oracle, Postgres, SQL Lite, SAP SQL Anywhere, and then obviously I've mentioned the ODBC driver, but also the Teradata driver and the NoSQL database platforms, and then also part of the Enterprise Edition. Now, beyond that, there's also a few additional features that are in the Enterprise Edition for database administration and also event alerts, which don't make sense on a local database because you're the only one accessing that data. But for the for the Enterprise Edition, where other data sources are going to be making changes to that data, then having those kind of notification parts kind of makes sense. So some exceptionally powerful storage. If you're not used to FireDAC or you've not used it before, its background was written as a replacement for the BDE, the Ball and Database Engine, which was very, very popular from Delphi 1 all the way through up to recent times. Unfortunately, the BDE has limitations in terms of 64-bit support, and even has some 16-bit elements within it, which means it's not really ideal for today's world. But the FireDAC was written to support the same bidirectional data sets and all the other kind of rich features that the BDE brought database developers for many, many years. and is really a big step up from things like DB Express, which was the original replacement for the BDE, which had unidirectional rather than bidirectional data. So it's a much richer framework. There's also great abilities to debug and do performance monitoring of SQL very, very quickly, just by dropping a couple of components and then using a remote application to see everything that's happening through the app. Now that provides a whole kind of additional layer within the whole kind of DevOps approaches. So it's some great capabilities within FireDAC that you have within the Enterprise Edition. Okay, so let's have a look at the second reason why developers choose RAD Studio Enterprise. Really, it's pretty easy to sum it up. It's the middle tier. Now, what is a middle tier? Well, most applications traditionally started off as client-server. You'd have your database on your server, and then your client applications connecting directly into that. And then we moved into a middle tier, which things like COM and Midas technologies were built, which allowed you to have the database layer, the middle tier with the business logic, and then the client, which then connected into the middle tier for the data processing and so on. And that's pretty much what we're looking at now. Now, middle tiers are great for being able to combine multiple different systems and databases together into a single layer, which can then be accessed by the client. That gives you a single sign-on in and the ability to then do a lot of the business processing and business logic within this tier here, hiding away the complexities of the back end to the client development. So this can be very powerful if you're looking at having changes or updates to the business logics based on different systems. You could even migrate, from one system to another, swapping out system 1 for system 2 over time, or even changing this for system 3, and then the middle tier updates the back end, but the connectivity to the client doesn't change. So it's great for being able to hide away and simplify some of the changes that you need in the back end. So multi-tier development uses the client-server technologies that we've just been speaking about with FireDAC in the back here, being able to actually connect to databases across different machines, having the ability to actually load balance and have multiple tiers, so you could have the same kind of middle tier but run across 5 or 6 different servers to enable scale, and that then connects to the same databases but from different servers. So having the client server functionality of FireDAC is very, very powerful when it comes to kind of multi-tier development like this. And we've really seen kind of the rise of middle tier in recent years, especially with the whole kind of web and cloud-based environments that we're seeing and architectures that we're seeing today that are very popular. Now, that's seen a massive shift from what originally was done through COM to now being done through kind of HTTPS and having the secure connections with REST and everything, doing the connection between the client and the middle tier. So still, you can be doing whatever kind of database connectivity or file access or whatever it is on the back end, and then just simple REST movement of data back and forth. Now, in terms of the setup and deployment of multi-tier, we're often seeing a lot now of things like Docker being used, which are containers, and the containerization of the middle tier, and also some of the back-end business logic. The containerization is something that we've been looking at Embarcadero, and there's support for that within RAD Server, which is one of the options for multi-tier development. And that makes it very, very easy to then build and test and check the configurations from the development machine using kind of the containers and the setup, and then having the same setup then pushed directly to live. So there isn't any kind of unknowns that you're going to fall about, because you're testing on the exactly same environment and setup and configuration. And that will kind of bring us nicely into our number 3 when we get there, our leave that as a slight spoiler for the moment. So in terms of the multi-tier options, obviously RAD Studio Enterprise Edition with Delphi and C++ Enterprise provides 3 different options that you can use. There's DataSnap, there's RAD Server, and then there's the web services. So DataSnap and RAD Server are the 2 that are kind of really the key points here. DataSnap provides the ability to have session-based managed middle tier, so you can enable full callback functionality with a live handle directly from a database from a component within the application. You can also have paging of data very, very easily with a T-client dataset and the dataset remote dataset provider setting that up. So very, very easy to do. RAD Server has a very similar approach for some parts of that, but RAD Server isn't just the kind of data connectivity part and the remote functions that DataSnap provides. RAD Server is a full MEEP with push notifications and a number of different things, which we'll just have a quick look at those here. So in terms of the difference, obviously session management is available on DataSnap, but not on RAD Server. RAD Server is RESTful by its design. That doesn't mean that you can't page data, and there's some great functionality embedded in for paging data and pushing page 1 or page 2 or page 3, but managing that fully through REST query calls. RAD Server is fully RESTful. DataSnap can be set up to be REST-based, but also has the ability to have the full active session management. The authentication is built into both platforms, and as I was saying, RAD Server provides additional push notification and embedded secure JSON storage, which is powered by Interbase. There's group access control management as part of the embedded user authentication that is part of RAD Server. There's also the ability, if you're doing an OEM deployment, to have multiple tenants running from the same RAD Server instance, which is amazingly powerful because that then provides you the ability to have multiple different sets of user security and the group management and everything depending on the tenant that is connecting in, which means that you can have multiple clients sharing the same server because it's all multi-tenant. One of the great things with RAD Server is that it uses Swagger to provide full REST API documentation. There's a kind of standard documentation built in for all the core functionality, and it's very, very easy to attribute the APIs that you're exposing just with some simple methods. Simple attributes that you put onto the methods that you're exposing, and that then provides a full, rich, interactive documentation with the the open Swagger UI, which is used by multiple different platforms and languages. There's also API analytics built in. Now this is very, very powerful, especially if you're looking at configuring and managing when stuff is going to be done to your server. So if you need to schedule maintenance, or also if you want to look and see, well, we've put this API together, when is it getting called? Who's calling it? How often is it being called? Is it something we need to support for the future? You can literally go in and find out which users are connecting in, how often it's being called, and so on. So that might give you a much richer prioritization in terms of the development that you're doing for your server and your middle tier that you're putting together, with a real rich insight that you can feed into the business. So this is a quick overview of the architecture of RAD Server, just to kind of give you the idea. So there's an Interbase database behind it, which is just for the management of RAD Server. You can then connect in for anything that you're providing out to any database. The Interbase database is provided because it's very, very fast, very small footprint, but then provides fully secure data storage for the user security and all the power on the back end, and whatever data you're pushing into it, it's fully encrypted and secure at rest, so you don't need to worry about that kind of side of things. And that's the kind of same kind of feature functionality that you would be looking at on a $50,000 licensed version of SQL Server in terms of some of the security level at rest data storage. So there's then two parts of RAD server. There's the EMS server, which is basically what you build your endpoints to run inside. And then there's the console, and the console provides the analytics and management console element of it, which you can then log into as a back-end user. And they're deployed as two separate applications, so you can put them on different machines to keep one completely private inside the network, or have it as accessible via VPN, and then putting the EMS server out onto machines that then allow it to be accessed remotely or wherever you need to. So great flexibility, and then everything is then provided out through REST. So one of the other things I've mentioned, kind of push notifications, the data storage, the user management, they're all part of RAD server. But one of the other things is this user location proximity detection, which we call beacon fence. And it uses Bluetooth beacons. You can set up and configure as many as you want. You need at least 3 to be able to triangulate a location. And basically it gives you almost like the ability to do indoor and outdoor, kind of almost like a bit like a GPS kind of tracking, but specifically inside buildings where it's hard to kind of get accurate tracking through normal methods off a phone. Using beacons can give you exceptionally close and accurate location sensing. So we have use cases, for example, there's a museum that is using this inside where they have multiple beacons set up. The visitors are then able to use a mobile device to pick up exactly where they are within the museum, and to then be able to identify specifically which exhibit they are right at. And the exhibit details will then automatically be shown on the phone. And if you've got kind of audio data with multiple languages, this is a great example of how something that is part of RAD server can be used to then add a very, very powerful feature into the application. So if you haven't checked it out, definitely something that's worth having a look at. Use cases for enterprise. Obviously, you can look at where people are within the office, which desks are actively used. If you need to be able to find a hot desk at the moment where it's quieter because you want to reduce the risk of COVID cross-contamination where people need to be into the office, then again, you can do that. And in terms of monitoring who is in and where they are and the locations they're in, then this is again key for being able to monitor that and to provide a very, very rich intelligence that you can then track and work with. Now, on the diagram here, you can see kind of different zones that have been set up. And you can also set up very, very easily, as somebody walks into a zone, you get an event method fired on the application, and it then is able to then react and do something accordingly. So you could check as people are moving from zone to zone, do they have access to be there? Should they be there? Even down to the point of if somebody gets next to the door for the IT desk, for the IT server room, should the door be opened up because they're part of the team, or should it stay firmly locked? These are kind of things that you can then start having things interacting with. Very, very powerful and worth having a look at. So before we move on and have a look at the third item in our top reasons developers are using the Enterprise Edition, let's have a quick look at some of the RAD server elements in operation here. And specifically, I just want to highlight how easy it is to push data out and have a fully interactive REST API very, very quickly. So I've built this using the wizard, so just go File, New, Other, and then under RAD Server, you can create a new package or a new module and just follow the wizard through. And it will put the components that you need directly onto the form and give the resource name attributes in. So my resource endpoint here is called exams, and we can see here I can just change this attribute for the class to change the name. And on here I have my query exam. I also have this TEMS dataset resource, which then allows me to define if I can list, get, post, put, or delete. So basically, fetch a list, fetch an individual item, update, delete the individual items that are in the query. I've got a key field which I'm using to identify the detail within the records. But also, this is actually quite a complex query in here. So rather than just having a standard query, which is quite easy to expose using this REST dataset adapter, I've actually got joins happening with different tables to fetch back extra information. So here the basic table is a set of exams, and then each exam is made up of a number of questions, and each question has a number of answers. So the first thing I'm doing is just returning back the exam headlines and the number of questions, so I can see quickly on the client side how many questions are in each exam. So we can see we can execute that here quite easily. If we go ahead and just run, I've already got it running here, so I'm just going to close that down here. We get a list of the endpoints exposed up. So we can see here I've got exams, putting the exam ID and then the questions, which is this one here, and then that will give me the questions for a specific exam. So let's go ahead and have a look. So we just have a quick look for the exams. So here are the exams. If I want to choose a specific exam, so maybe exam 1, I can see here's the exam, and then the questions. I need to remember to put the endpoint on. There we are. So here I can see the actual specific questions. Now this is great. I've got the questions. I now need to fetch the specific answers, which can be kind of quite long-winded. So what we've done actually, I've added in this questions full, which provides the exams, the questions in the exam, and then the answers for this question. So to do that, rather than having combined data sets, I've actually done this using just a little bit of code. So here we have a get method, and this is the entire code for that. So a query, and then checking that the exam exists, and if it doesn't, returning an invalid exam ID. Otherwise, I just kind of fetch the data, take the first question, and just loop through, use the response body JSON writer to start the object, put in the data for the exam, and then add in the answers. And you can see here at the top I've got a quick method just to convert each record into the JSON array. So very, very simple data. And that gives the example of the exam questions with all the answers. The one thing that we can do here using FireDAC as well, to allow the update of the exams using the post here, I've actually got this update SQL, and here I can see I'm able to modify quickly the insert, the modify, and the delete. So I can actually take the data that's being returned back and just say, look, ignore the questions part. Use this to build the SQL statement that we're going to use to update the record in the database. So just by doing that and providing the SQL mapping, I don't have to write any code to have read-write operations on that table directly through a REST API. So this takes literally minutes to put together to provide full capability, and this component can also handle things like sorting. So I can do SF and then the field name to sort by that field name with the result data set. I can do paging, so I can put a query for page and the number of records I want to return on that page, and so on. So it's a very, very powerful way to provide a rich user interface to your data that can be consumed by a web application or another or any other application, be it a desktop application or something written in any programming language. So that's pretty cool. Okay. So number 3 on the list has got to be Linux. one of the amazing things you can do today is obviously take your existing code and recompile it for the Linux platform. And that provides much lower cost of ownership and ongoing serviceability of your servers, which helps improve your margins, but also makes it a lot easier from a development point of view to incorporate some modern development practices like DevOps, to be able to test and configure using a Linux Docker container or other Docker or other container software from your development environment all the way through to production and test everything with the same things in place, which obviously makes it much easier as you bring products and software to market and to iterate faster and so on. So the Linux support provided includes the latest long-term support editions of Ubuntu and also Red Hat Enterprise. Now, additionally, you can also build desktop applications using FMX Linux and the plugin that is added into the IDE now for enabling the Linux platform to have a UI provided by the FireMonkey components. So using FMX Linux, you can use your existing macOS or even Windows applications if they've been written with FireMonkey, or even take code from your mobile applications and get that directly across. Now, with the runtime support and all the system files provided by Rad Studio supported across all the platforms, it means you're really close to getting to Linux today already. And the ability to deploy directly from the IDE to a Linux box as well using PA Server makes it exceptionally fast to build and to deploy applications even directly from the IDE up to a Linux server. So this can be exceptionally useful, especially in a development environment, or even if you need to push build outputs directly from your local machine through to a remote server. Everything you need on the deployment settings, in the file setup, in the folder setup is really flexible and is fully there for Linux to make it an absolute breeze to deploy everything you need in the structure you need it directly up to the Linux box, directly from the IDE, and have that repeatable time after time. Now, in terms of the desktop applications, one of the things that is quite popular with customers is kiosk applications. So being able to have a locked down OS that has your desktop application running on it in full screen mode is a fantastic way to be able to reach out to provide rich functionality that allows users or customers to interact directly, which is fantastic. Number 4 on my list of 5 reasons to choose the Enterprise Edition is Interbase to Go. So those of you who are not familiar with the Interbase to Go version, Interbase comes in 2 versions. There's the Server Edition, which runs on Windows, Linux, or Mac OS, and that provides the ability for devices across the network to connect into a central database. And then there's Interbase to Go, and Interbase to Go brings a very small footprint database engine that's exceptionally powerful inside your applications. It's embedded directly inside the application. So as the application starts up, the database engine is available uniquely to your application. So in terms of being in the same memory space, it's very fast to work with. But the thing that really sets Interbase to Go apart from other database platforms when it's completely embedded in is the full user security, the full on-disk encryption, which provides the best in terms of data protection, and also things like industry standards like PCI compliance. The encryption levels within Interbase allow you to have different data using different encryption keys. So, for example, if we talk about PCI compliance credit card data, where you need to have a separate security encryption code within the database for the credit card details compared to other personal data that you might be encrypting. You can do that because you have full column level and database wide level encryption of the data. Having the full inbuilt user security allows you to provide decrypt functionality to specific users, allowing you to have managers and say, for example, HR people, defined by their role, access to different data with default values if people don't have access to it. So, for example, you can still do select staff from employee, but only the HR people will be able to see the column that gives the current wage for that person. So, great for being able to do a number of different kind of setups. Now, the Interbase to Go license that's included in Enterprise is for iOS and Android. So in terms of deployment to the app stores or onto corporate devices that are being shared with people who are mobile, then you have full encryption at rest, which is fantastic. This makes it ideal for kind of going out and doing on-site maintenance and job records or whatever you need to do, capturing things off the phone, camera, into the memory, storing it with the jobs that are being processed for the day, having all that data locally cached so you don't have any worries about internet connectivity in the deepest, darkest concrete jungle, wherever you are. But one of the great things about Interbase to Go is it also includes the IoT award-winning Change Views capability. Now, Change Views allows you to track and provide data out to multiple different endpoints. With a simple device ID, you can start a subscription active on the database, run your normal SQL, and it will then just give you the delta of what's changed since the last time you ran that SQL statement. And you can then cache that, do whatever you need to do in terms of taking it from the local device, putting it back to a central server, and then committing up to that point. So it's amazingly powerful in terms of moving data around. The actual IoT award it won was for most innovative use of data at the Total Telco Awards, which was a global award, which was fantastic. And one of the amazing things from a developer's perspective is having Interbase on your development machine. It's the same on-disk structure for the databases that works out on the mobile platforms as well. So as a developer, you can actually get the database back. You can work with it on your machine if there's ever any issues or things that you need to look into. But the great thing about the encryption is that even as a developer, you can take the database and still only see the data that you should be able to see based on your role. So even if you took a database from a production machine that had HR information in it and you ran select staff from employees, because your username and password don't provide access to the HR information, you're not going to be able to see it. So in terms of a compliance point of view, it provides something way beyond the kind of level of security that you can implement and justify with things like Ssl Lite on a mobile platform. So just to show you how easy it is to use it, I'm going to show you an app that I've written myself that's in the app stores and uses Interbase to Go on the mobile. So here is my application code, and I'm just going to show you quickly the data module that I have for the database. And I share this data module between a desktop application that I use for putting a whole load of configuration data together and data that's populated for remote tables, and then ready to syncing it back and forth. So my database connection here is common. I've got my database, I've got my physical IB driver link, which basically connects it up to Interbase, and the GUI wait cursor. They're the only three controls that I need for the basic control of it. And within the database connection here, we'll literally just set the path to the file that the location where it is. My username, my password, I've just changed for stars, obviously for specific reasons. And then the only other thing that you need to set up is the SE password. So that's a secure encryption password. That is created at the point you create your database for the first time. And once you've created the database on your development machine, all you need to do is then just make sure that it is actually deployed to the device with your application. So under project deployment, all you need to do is come in here and add feature files, tick the interbase to go, and that will enable that for the platforms that you want to run it out to. And then the only other thing you need to do is just put the database in. So, for example, let's just find the database. So here I have my local path for the database from my project, and here I can see the directory that it's going to be pointed out to. So startup documents, and in fact, if we just click on the local path here, this is the iOS 64-bit. If I go and have a look at the Android 64-bit, you can see it's just .assets/internal, and using that, I'm then able to just at runtime, as I create my data module, I'm able to just set up here that if it's not on Windows, use the set the driver link to be Lite, which means it's the embedded version. That's FireDAC's way of saying use the embedded version. And then I can just use the tpath.getDocuments path and put in the database file name, which I've got listed as a constant above, and just set the database path. And that's it. That will set the database pathing, connect to the database, and off we go. So it really, really is as simple as that. That's all you need to do to have it working on your desktop and on your mobile device. So the fifth thing to speak about is the enterprise connectors. Now, one thing that is clear today is the world is shifting towards these microservices, shifting towards software as a service, where there's lots of different applications that we're integrating and working with. And on average, enterprises are now sorting out around about 20 different SaaS applications that they're working with, be it from SAP to Office, to Jira. There's a whole host of different things that you could be looking at, and one of the things that the enterprise connectors gives you is the ability to connect into over 90 of these leading enterprise systems, but by extending the FireDAC connection with special kind of drivers that basically then almost treat these enterprise systems like another data source. And then you can query them and interact with them using pretty much standard SQL. So rather than having to write and decode and sort out all the different APIs, you can just link to the enterprise connector and put the data in and work with it. So these enterprise connectors, they are royalty free for distribution within your enterprise. If you are going to be embedding them into an application and distributing them, then there is a runtime fee for those. However, obviously, if you are looking to use them and embed them into your applications and you're hosting your application, then you have got the ability to put them on your server and use the connections. So one thing that these really come into power on is behind something like RAD server or DataSnap, where you can host a single sign-on and have all these different enterprise connections coming back into the organization through a single point of access. That's the beauty of having a good middle tier, is that you can use things like the enterprise connectors to bring and to merge all that data together quite easily on the server side. Being able to query multiple different data sources, combine them, and then provide the resulting data set back, it is immensely powerful. So I'm just going to quickly jump here to the Embarcadero website. This is by far the best place to come and have a look at the details of the enterprise connectors. There's a great page here that lists all 180 plus and growing, it's constantly growing, of the enterprise connectors. There's the ability to kind of get directly into some samples, and you can see exactly how easy it is to select specific stuff here. This is from Salesforce. So you literally just set the driver name in the FIDAC connection to cdata.fire.salesforce, and you can then set the parameters up, set the queries active, literally do select star from accounts where industry equals healthcare, and you've got full access to that data. It works with SQL compliance. You can interjoin things, aggregate functions together. Very, very powerful indeed. And in here you can see the Enterprise Connector Professional. That's the version that is included with the Enterprise Edition. And then there's the Universal, which is there's additional ones that you can buy and add on. But you can see here straight away, everything in white is included through. Things like Act CRM, Facebook Ads, MailChimp, which is very popular for mail merge and mass mail. A lot of accounting software from FreshBooks all the way through to Zoho Books. Some great SaaS solutions. A number of different SQL database, NoSQL and big data databases. Office 365, which I mentioned already. WordPress, which is obviously really popular for many of the leading websites that companies are building and using. And then even down to e-commerce, with direct access into PayPal, to Stripe, to eBay, to Woohoo, to Xcart, and so on. There's some great connectivity. And then also on the social networking side, things like querying what's happening on Facebook, Instagram, Pinterest, Salesforce Chatter, Slack, Twitter. There's a great chance to be able to directly access into all of these different systems. And then just do it with standard SQL. So a lot quicker and easier to ramp up and get deployed and get using and accessing in. And then again, further things like Amazon S3 storage. Obviously, we've got components for doing that as well. But again, this can make it quite easy to query some of that in a simpler fashion using SQL kind of syntax. And also Gmail, which is obviously very popular. So huge number of connections to have a look at. As I say, there's some great getting started examples to get you going directly from the website. And one of the things that is exceptionally popular within the Enterprise Edition. So that's pretty much it, really, for the top 5 reasons developers choose the RAD Studio Enterprise Edition. So to quickly recap, FIDAC obviously provides blazingly fast client-server connectivity, and that then opens up the door to doing access to data off the local machine. That plays an important role if you're looking to go to multi-tier at any point, and having tools like RAD Server with the full MEEP with push notifications, the analytics built in, all the user grouping and security that's built into the back end is phenomenal. Obviously, we have DataSnap as well, which provides closer integration to Midas and also has the ability to do immediate callbacks. With state managed from the server. So it doesn't scale as much, but provides rich functionality for immediate connectivity compared to RAD Server that is fully fledged MEEP with full RESTful and much higher scale. And then obviously Linux, which enables you to take your multi-tier development out to a much cheaper hosting and gain the benefits of having cross-platform native code blazingly fast across Linux, which makes it a lot easier to integrate things like DevOps into your processes and to have smoother movement from development all the way through to deployment. And then obviously we have Interbase to go. Interbase being an excellent database to choose to run across Windows, Mac, Linux, iOS, and Android with the same on-disk structure, with the exceptionally rich data security and easy access into features that you'd normally find in the top enterprise-grade databases, but deeply embedded into a mobile application, which really sets it apart from anything else in the market. And then in terms of accessing into the wealth of SaaS products that are out in the market today, the enterprise connectors expand FireDAC even further, providing exceptionally simple, low-code approach to getting into a range of different enterprise systems very, very easily, which is great for multi-tier development, or even can be used through normal traditional client-server applications. So that's it. That's my top 5. I hope you found this interesting. It's now time to open up for Q&A, and thank you for joining us. Okay, so hopefully you can all hear me fine, and I'm just going to try and see if just get the well, hopefully you can still see the questions panel up on the screen, which should be good. Okay, quite a few questions just popped through, so last chance to pop any questions in for the Q&A. Please go ahead and just post those in. But thank you for the questions that have come in already. There was a question from Stephen just asking, as of RAD Studio and the IDE element, but not of RAD Server. So yeah, RAD Server really came out from originally from Enterprise Mobility Services, so the EMS components that were added a while back, and RAD Server is basically the latest name for it, and it gives, as I say, full capability to run a MEEP within your application, and that enables the RESTful backend to rapidly share out data in a full REST compliant way, with paging and sorting and all those kind of things that you'd expect to have without having to write a single line of code, and the ability to control, the ability to insert, update, delete, list, or to just fetch a single item through the HTTP verbs that are part of the component that we had a look at in one of the demos earlier. So very, very powerful way to expose out data and get that accessible by any platform using REST. And then also, as we saw in the sample, you can still code and define your own data packets very easily if you've got edge cases that you need to work on or set up. So all of that is very easy to do with the JSON writers and readers, and just use some standard SQL, some standard Delphi or C++ code on the back end. So the way RAD Server is working there is it's actually producing packages that run alongside the core engine that's precompiled, ready to ship out. And as we saw, the ability to run that across Windows or Linux makes it very, very powerful and quick to deploy and get out. So there's also a question here about the enterprise connectors. Someone's saying they've got enterprise or recently moved up to enterprise, and how do they find the C data? Well, if you go to if you reach out to your salesperson or drop me an email, then I can send you the link over. Basically, there's a promotion page online which you can put your product key into, and from there you can then download enterprise connectors. Or it gives you the what you need to go and kind of get them. You can just visit the CData website to download what you need. So I'll put the 2 links into the chat. But if you don't get them from there, then please feel free just to send me a message over. Okay, couple of questions around the beacon fence. Some say they've been trying to use it, but struggle a little bit. Okay, one of the key things with the beacons is that there's varying qualities of them, and also you tend to get slightly better results from beacons that are plugged in rather than battery powered. However, that said, it really comes down to the frequency that you've got the beacons pushing the data out. The longer the time interval between their notification that they're existing and they're there, the longer the battery will last. But you can set up with many of them, you can have a control panel set up where the beacons tell you if they're running out of battery and all those kind of things, if they are just battery powered ones. But the key thing I'd say is make sure you've got them mounted as high as you can, because of the way Bluetooth LE works, and I can't change the laws of physics, unfortunately. Line of sight provides the most accurate results. So being able to mount them high on the wall, or even on the bottom of ceiling tiles or something, will give you the best response from the beacons. So definitely worth having a play around with. And the more you have, the more accurate result you're going to get in terms of the triangulation. Yeah, it's been a few years since I bought some, but I certainly found I had the best result from a little one that just plugged into a USB port and ran. And I used to be able to get very, very accurate response from that with line of sight. So a few of you agreeing in terms of the top 5 things here. Also comments and suggestions for other things that would maybe be in your top 5, which is always great. I've mentioning here, some of the modeling support within Enterprise Edition is absolutely fantastic and really useful. Absolutely agree with that. Being able to model and view your objects and how they link together is a great way to be able to visualize your code in a different way, and helps you kind of code in a more productive way. That's again, another top reason to move in, but one that's been around for quite a while now as well. So trying to pick a few of the slightly newer bits around the edge. Yep, mentioning the UML modeling and also some of the code analytics. Some of the code analysis stuff is good. A few of the bits are a little bit outdated now because they've not quite got the latest support for some of the newest language features that have come through. But still, a very useful way to pick up and see what's in your code. And they still do provide a certain amount of power. And for those of you who haven't seen the DevOps infographic, then if you Google Embarcadero blogs and infographic, you'll be able to find a really nice infographic with lots of different areas that RAD Studio fits into around DevOps. And there's some great third-party components and plugins that provide some great functionality within those areas as well. So code analysis is obviously a great thing to look at, and available through the product and also through the community. So a couple of questions that are kind of off topic, so I'll probably kind of just defer those onto another session another day, specifically about Linux and ARM processors. But yeah, it's something that's always being looked at and considered and monitored. I know if you've got specific business cases, then more than happy to hear your business case around it, because if we can show the right business case for the community, then that also gives us a better chance of being able to invest the substantial amount that we need to into new compilers and to bring those forward. But obviously, with big outlay to put into it, we need to make sure that the business case stacks up for everybody to make sure we can get that to market for you. So if you do have a big reason for getting that, then please feel free to reach out to me or a member of the product management team. The other thing I would say is that there's many of the micro boards can be loaded up instead of with kind of Raspberry Pi, can be loaded up with things like an Android distro. And obviously, if you can get an Android distro working on it, then you can reach that today with Rad Studio. So definitely worth having a look at if you can get Android onto the boards that you're looking at, or look for another alternative low-cost board that you can run Android on. There's a question earlier on about the BDE, still using it. I'd definitely say if you're still using it, it is time to maybe look at other options, especially with the the security implementation implications that the BDE has. Especially with the 16-bit and the kind of the weak security elements around it. Certainly wouldn't be putting kind of major business application data through the BDE nowadays. Especially if you're wanting to kind of keep on the right side of the legal requirements around GDPR and other kind of storage of data and personal identifiable data. The great thing is that there's a very quick and easy way to move off the BDE, and FireDAC is the ideal replacement for it. And the way to do that is using Refind, or there's commercial tools that are available that do a great job helping migrate and modernize code as well, like the Delphi parser. So there's a number of options to look at to help you move up and to keep modern. Yeah, Thomas just asking further out the boards. I believe if you Google Malcolm Grove's Android and Raspberry Pi, you might find a blog post he did a few years ago now. I think he was using a BeagleBone Black or something. I can't remember the exact name of the board, but he had a very similar board that was getting an Android distro running up on. So there's a number of different ones that you can look at. Okay. Just kind of having a quick scan at a couple of the other questions here. Okay, I think I've pretty much covered the core ones that are being put through there. I can't see anything else that's particularly uncovered in terms of the answers that I've pushed back. So I think we're almost at the top of the hour. So thank you everyone for joining us today, for the questions, for the conversations. If you do have any questions, or if there's anything that I've missed that you'd like to get a response to, then please feel free just to drop me an email over, stephen.ball@embarcadero.com. If you are needing any further advice or want to have any further conversation about anything that you've seen today, again, please feel free to reach out to me or your local Embarcadero representative, and we'll be more than happy to chat further with you to help you make sure you're getting the right thing for you and the work that you're looking to do. So keep an eye out on the blogs for more news and events, and also some exciting stuff that is just around the corner. I'll leave it at that for the moment. But yeah, keep an eye on the blogs, especially over the next few weeks, and look forward to being able to welcome you back onto another webinar very, very shortly. Okay, everyone, take care, keep safe, and see you all soon. Goodbye, happy coding.
This is a quick follow-up to my last video where I showed FireMonkey and live bindings. This one I'll show VCL and traditional bindings. We go ahead and create a new C++. This time I'll choose VCL application. VCL also supports live bindings, but it additionally has the traditional bindings. We come over here to the Data Explorer interface, FireDAC interface. This works with other databases as well. And I will choose the employee databases, or employee table this time. Again, this is the connection to the database, the FD connection component, and this is the connection to the table. You can edit the query. By default, it's just select star from table name. You can also execute it if you want to see the data and the structure. And I'm going to add the fields, although that is not required. It's just convenient. This time, I'm going to put down a DB grid. Anything that's prefixed with DB or TDB is a data-aware component. There's a number of those here. Actually, I'll show you those real quick. So these are all data-aware. They know how, well, yeah, those are all data-aware. That one's a separate one. But they know how to talk to a data source. So I need to put down a data source now. There's my data source. A data source is the connection between a data set, which is any query or table component, and a data-aware control. So if I go to the grid, it has a data source property. Anything that's a TDB has a data source property. And I can, a shortcut, you can just double click and it will select one of them. Since I only have one, it selects the right one. And if you hold Control and double click, it will then take you to the linked component, which is the data source. And I'll double click here again and select the data set. And then I'll go to the table and I'll say active true. And there we go. Now it is displaying the data in here. The live binding, like I said, is an option here, but I'm not using it this time. Oh, and I will add a navigator, TDB navigator. There we go. And I need to attach the navigator to the data source. And we're good to go. So I do need to add my one line of code. This would be different if I were doing Delphi, where in this case it's C++ builder. And I need to type the, I forgot my name of my employee table. Open. I guess the Code Insight's up there as well, but I was faster than it was apparently. And at this point, I'm ready to go, so I'll go ahead and run the application. And here we're in the table, so I can change this customer's last name to Robertson because that's funny. Post the data, refresh, can navigate in here as well. New record. If I change it to Roberts, as soon as I go to the next row, it posted as well. And you notice, I don't know if you'll see it or not, but the cursor changes real quick as it's doing database access. That's to give your users a visual indication of what's going on. Anyway, that's it. Quick, simple, data-aware application with FireDAC and Interbase, and this time VCL.
Hello everyone and welcome. So in this video I'm going to show you one of the, for me, the coolest way to read and write into Excel documents, and it is, believe it or not, by using ADO components. So if you ever used ADO components to communicate to some database, now you can use it to read and write into Excel documents. So I have here data XLS, that is Excel document, and it has 3 rows, as you can see. First one describes the columns, book name, author and year, and those are the 2 books. Okay, so let me run the application, and as you can see, tables, these are practically worksheets, list 1, 2 and 3. So let's see, list 1, 2 and 3. So these are the lists available. He recognizes them as tables, but never mind. Okay, so I'm going to say I'm reading from a list 1, read data, and as you can see, he read book name, okay, the passage, country and author and year. So pretty much he read what was inside this Excel document. And watch this, when I add another line, he automatically added this inside Excel document. Okay, so I can change it into something else. Okay, add another record or line, going to another column, and that's that's pretty much it. It's really simple and really easy. How to do it? Well, let's see the CPP file. So this is the code required to do it. First of all, you need to specify the connection to Microsoft Excel document. You will be using this provider. Although if you are using a 64-bit version of your application, you'll probably not be able to use this jet provider. You would use ACE or something like that. So that's not really the problem. But under the source, you need to specify data, meaning your Excel document. Extended properties equals Excel. Okay, Excel some version. This is Excel 8.0 for .xls. I believe the 9 or later is for XLSX or something. It's really not a problem to check it out. And once you specified the connection, meaning the connection string, you simply apply it to ADO connection component. And using this string list, you get table names, meaning the worksheet names, and you add those names into a combo box. So this is the combo box where the worksheet names will be placed. And once I click this button, I simply execute your SQL query, and that is select from worksheet, list 1, 2 or 3, simply select all data. Okay, so I could have specified select only some row or something like that, and once I hit this ADO query 1 open, it physically connected to this document, and when interacting with this DB grid, I was automatically actually writing inside this Excel document. So as you can see, I will show the code again. It's really easy and simple, and for people that don't have requirements like want to change the color of cells or something like that, you can really use this approach, since like I said, it's really easy and simple, and for me pretty cool. Okay guys, thanks for watching and see you soon.